Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera untuk kita semua. Good morning, ladies and gentlemen, distinguished guests, respected keynote speakers, esteemed faculty members, participants, and friends from all around the world, on site and online. Welcome to the 9th International Conference on Recent Trends in Computer Science and Engineering, RTCSE, organized by Gian City Research Consultancy and proudly hosted by Faculty of Information Technology, Yarsi University, Jakarta, Indonesia. It is truly an honor for us to gather today to share insight, explore breakthroughs, and build global collaborations in dynamic field of computer science and engineering. To officially inaugurate this prestigious conference, we are delighted to present a series of keynote addresses delivered by 3 distinguished experts whose contributions have greatly advanced the global tech and healthcare sectors. Please join me in welcoming our keynote speakers. First, Mr. Busan Chavan from MRI USA online.
Hello, good morning all.
Morning.
Okay, so first of all, thank you so much for giving me this opportunity, and I'm very happy to represent as a speech here. So just want to start with the one thought. If you don't mind, I'll share my screen and then we'll get started with that thought. This thought is a lifetime lesson for me. So as I'm just trying to share my screen. Let me know if you can see my screen.
Yes.
Okay, can you see? Okay. So I have learned that people will forget what you said. People will forget what you did, but people will never forget how you made them feel. Maya Angela, that's the thought coming from. I'll stop my screen share, and this is what I learned in my career, that whatever you're going to do, everybody will forget. If I leave my organization, somebody will take my place, and then somebody will come and then carry forward. But if you teach somebody to feed their bread and butter, nobody will forget you. I never forget my first guru or my first teacher. Same thing with like Mr. Bishwajit. I'm very glad I'm connected with him, and then we are collaborating here. So I'll not take too much time. Then I'll get started on my introduction, and then we'll jump into the topic. So my name is Bhushan Chavan. I have 22 years experience in InfoSec department, information security. I'm working as a director of software engineering into the MGM Resort International. In United States, we have Vegas, where we have almost 20 properties. And then on regional, there are 6 properties, other states like Bogota, Detroit. These are the other properties. So my key role here is to secure the workforce of the MGM. Like we should protect into the cybersecurity for them. So that's my role, key role as engineering. And we recently had a cyber attack in 2023. I played a crucial role into that one. That was a big achievement for me, what I did in 2023 September. The group was Scatter Spider, who attacked on our organization, and then they hijacked almost 6,000 plus servers. However, that was a good lesson learned from there. Now coming back to the sale point, the technology which I'm using right now. And the sale point is the technology where we are monitoring, or we are doing the joiner, mover, and lever, the workforce management I'll start sharing my screen and then slides, and then we can go on to the slides. Let me know if you can see my screen.
Yes, yes.
Okay, so uh, let's get started. So everybody know the cybersecurity, but the core function of the cybersecurity, people are forgetting the core function. Everybody's thinking hacking is the cybersecurity, or the hackers is the only cybersecurity, but that's not the fact. That's not so true. Cybersecurity is based out of six core pillar, which is on my screen right now. Uh, it's a six hexagon. So I'll start with the PAM. PAM is a privilege account management, where we will do the privilege account onboarding and vaulting, then service account and secret management, operation and maintenance of the PAM tools. That is come into the PAM domain, which is the subdomain in the cybersecurity. The next domain is a TDR. TDR is nothing but a threat detection and response. In TDR domain, we get a threat detection, threat response, threat hunting, cyber threat intelligence, and incident response. Next domain is TEM, Threat Exposure Management, vulnerability scanning, secure configuration scanning, vulnerability lifecycle management, risk mitigation support, and enterprise integration. Next part is AS. AS is application security, which is static code analysis, dynamic analysis, integrated analysis, application attack and penetration testing, security architecture review, and threat modeling. Next is the DP, which is the data prevention, high value asset identification program, data loss prevention program, intelligence, privacy automation. And then last part is the digital identity, which is my bread and butter since last 22 years, which is the access enforcement, identity governance administration, operation support and services, and application onboarding. So these are the core six subdomain of the cybersecurity, and everybody only familiar with the TDR in the industry. Nobody know about the PAM. Nobody know about the DI. No means there are audience, but when we go into the education sectors, we generally focus on the TDR, but not onto the other subdomains. That's my impression. Again, I might be wrong, but that's my impression. So moving to the next slide. So digital identity, where we are going to focus on this domain today. I will be happy to love again in the future as well for the other domains to explore, but I will go ahead and explain right now into the digital identity. So digital identity has access enforcement, identity governance administration, operation support services, and application onboarding. So these are the four subcategory into the digital identity domain. So in corporate world, two type of workforce management is happen: employee workforce management and customer workforce management. Today we'll explore the employee workforce management, and below is the employee life cycle. How does employee join? How when employee left, what we have to do, and when employee get transfer, what we have to do. So that's about the process. So I will talk about my company, MGM Resort. So HR will contact to the new person and he will tell, okay, I'm joining on the 25th of June. Then IT department will trigger his joiner flow, where we will give him a birthright access like access card, laptop, primary credentials, and then business role. What is my job duties? My job duty is a director of engineering. So what access I do need it. So that's the business role. Then we will talk about the mover. If I get a promoted as a promotion, or I get a transfer into the another department as a vice president, then it is called as a mover, which is called as a transfer process. In that process, my role is getting changed. And then sometimes, if some person got married and then they change their first name or last name, or somebody changed their name due to the life cycle event change. So that is all come into the transfer or mover process. Now, last part is leaver. For example, a person called as a John who want to leave the organization, he submit the resignation. So at that time, leaver is going to trigger. And when leaver is going to trigger, we have to remove his access on the day of exit. So that's about the joiner, mover, and lever. Looks very simple, but when you go into the detail, it's required a lot of coding, a lot of application onboarding into the sale point. We will cover into the next slide. I will go and I will explain that next slide. So for any questions?
No, you can continue, sir.
Okay, perfect. Perfect. Thank you. Okay, so next is we are talking about in corporate world, there are many tools available in vary organization to organization. There are different type of vendor who has different type of tools. We are focusing on the sale point, but if you go into the industry, you have IBM, you have Oracle, you have Omeda, you have One Identity, you have Microsoft Enter ID, you have RSA, you have Ping Identity, you have Okta, you have Savient, you have Empower ID. These are the different tools which are the competitor for the sale point. So we are just exploring right now sale point, but there are many tools available in this industry, in this domain, which you guys or student can explore onto this one. Moving to the architecture, when we have the sale point into the organization, the how sale point will work. What is the architecture for that? So I'm going to explain here that identity governance and administration. So any new hire, any termination, any rehire, any transfer, any profile update will be marked into the HR system. So I'm just showing as example Workday. Workday is a famous HR system that all transaction happen into the CMS system, and that system connect on a daily basis, a real time with the SailPoint tool, and SailPoint sync the 30 attributes from Workday to SailPoint, and then SailPoint will connect with the multiple application and then try to provision the access onto this application. So applications also need to be onboarded onto the SailPoint in terms of we have to do the connection settings between these two applications, plus the API calls or disconnected. There are multiple workflows into this one. So that will come into the onboarding part. I will explain that into the next slide. But the key concept here is birthright and role-based access control, and then setup access. So this is about the architecture of identity governance administration. In short form, some people called as IGA. So which is identity governance and administration. Moving to the next slide. So whenever we want to onboard this application like Okta or ServiceNow or Bloomfire or Coupa or Kronos or Oracle into SailPoint, there is a checklist is available. This checklist is created by me after my 22 experience. We learn a lot, and then I created this checklist. When we connect with the application team, we ask them the question, hey, does your application support the provisioning based on the ED group or Okta groups? ED means the Active Directory groups. If yes, then we'll go with that particular route. If no, then we ask the question, does your application has a SailPoint native connector, built-in connector for the SailPoint? If they say yes, then we go for that architecture. If say they no, then we can ask them the next question. Can your application consume Scheme API? Scheme is a protocol. Can your application support the scheme provisioning? If they say yes, we go for that particular architecture. And if they says no, then we ask them that, does your application support the RESTful API? If they says yes, web services or any RESTful API, then we will go for RESTful API. If they says no, then we'll ask them that, hey, does your application support the provisioning based on the database? Like if you can make an insert statement into your table, can that approach will work? If they say yes, we'll go for that. And last is, which is not my favorite, manual provisioning. So in this case, we will just create a ticket into the ticketing system and assign to somebody who is manually adding the access into that application, which is called as a manual provisioning. And manual provisioning is a lot of risk associated with that. People can make a mistakes. So that's why it is my least favorite. So, but this is the architecture when we, or decision tree, when we onboard any application into the SailPoint. Moving to the next slide. So this is the employee joiner process flow. When employee join any organization, HR feed that information to the HR systems, and then we put that code into the SailPoint, and SailPoint will see that, okay, any connector is available for application. If yes, then we will provision the access to that particular user into the multiple application. If that connector is not available, direct connector, then we will create a ticket and then manually access has been provisioned by the SecAdmin team. So this is the employee joiner workflow. Moving to the next slide. So this is the employee transfer and mover process. In this process, HR will mark that, for example, John is going to transfer on the 1st of July. Then SailPoint will detect on what date transfer is triggered, and midnight it will trigger the process that they will remove the access on his old job role, and then they will provision the new access as per the new job role. And this is very critical in terms of audit and compliance, SOX, PCI, gaming rule. Just for awareness, we are in the casino industry, MGM Resort International. We have almost 20 plus gaming application, casino application. And in these casino applications, there are separate rules and regulation per state. In United States, we have 50 states, and we are running into Nevada state. Nevada is the state, and Vegas is the city where we are running the business. So Nevada has their own gaming board, and that gaming board has their own rules. If we found a guilty not renewing the access on the time, we have to pay $10,000 penalty per user for if access is not removed within the 3 days. So you guys can understand how critical compliance in terms of scrutiny. If they found anybody access is not removed on time, we have to pay $10,000 penalty for a single employee if they identify as a guilty. And my department is in charge of removing the access on time and adding the access on time. So we have a lot of Power BI dashboards and a lot of dashboards as well. Not only Power BI, we have a lot of dashboard which do the scrutiny, and we have 400 plus application. And the plan is in next 2 years we are going to expand in Japan and then China and then Dubai. So we are going to, after the expansion, 2000 application we are expecting. So this is very crucial part, and we will do the deprovisioning onto this application and provisioning onto this application. I'll move to the next slide. So employee leaver process. If anybody left the organization or want to leave the organization, they say that, hey, this is my last day, 1st of July. So once they say, today is my last day, uh, SailPoint will detect that day, and that day, midnight, 11:55 in the night time, will see on whatever application user has access. If that connector is direct connector with RESTful API or connector or everything is connected, then we can remove access automatically. If there is no connector is available, then we will create a ticket to the security administration team who will monitor these tickets, and then they will remove the access within 1 day as per the compliance policy. I'll move to the next slide. So if you visit this slides, sellpoint.com, this is the product we are talking about, and they have their own community, community.sellpoint.com. They have their own documentation called as a sellpoint documentation.com. So this documentation is very important. I will show you in a real quick. Let me know if you can see my screen. So if you go onto this screen here, you can see non-employee risk management, data access risk security, SaaS management, identity now. These are the different product available on documentation.sellpoint.com. And then there are two type of product. One is on premises and one is on the cloud. So we are working on premises software called as Identity IQ 8.4. But there are connectors are available. When I was explaining the different type of connectors. So we have Amazon Web Service connected, then we have BMC Remedy, then we have Coupa, then we have Dio, then we have Guidewire. These are the different application, and for this all application we have connectors available. Mainframe application, Microsoft SharePoint, Novell, Oracle, EPM, ERP, IBM, then we have Salesforce, SAP, SAP Direct, SAP HANA, Unix, WebEx, web services, Zoom. So these are the all different type of connectors are available. Then we have service desk integration as well, where you call to the service desk and then you tell the problem. So that service desk are different Zendesk, ServiceNow, and then password desktop reset. When somebody forget their password, they can call onto the desktop password support team as well. So these are the different documentations are available onto the last slide, which I just explained, community dots documentation dot sailpoint.com. These slides are available for everybody. I want the students or the faculty to tell to the student if they can visit this particular website and explore the more knowledge. I can guarantee if they explore the cellpoint.com, they will get jobs into the big fours. Big fours are EY, PwC, KPMG, Deloitte, where the lot of openings are in the cybersecurity area. Cybersecurity area is really grooming, and this is the one of the niche skill, the SailPoint tool. If they learn from this tool, they'll get a lot of job opportunity. Trust me. Okay, moving to the next slide, job opportunities. I hope you don't mind, but I will explore this job opportunities here. There are two types of job using the SailPoint tool. One is the engineering, which is my favorite area, which is my bread and butter, implementation. And then second is operation. Again, operation is bifurcated in two. One is administrator and one is operation. So in operation, we can do the managed services and then production support. And then third part is the compliance and audit. So operation where the technical people are not really hands-on doing the coding, but they can talk and they can plug and play. So that's about the administration and then operation part. The engineering where people are had hands-on on the Java, they can use the bin shell scripting, which is into the SailPoint, and that is called as the engineering team as implementation. So these are the two job opportunity sector which student can focus on that one. These are the just naming culture which will ask in the interview what is the birthright, what is the baseline, what is the RBAC, what is the policy, what is the joiner workflow, what is the mover workflow, termination workflow, risk-ended workflow, risk-ended rehire, audit and compliance. These are the just keywords. So that's about the sale point, but I would strongly recommend to student can explore onto the this different type of tools. Not only the sale point, we have Okta as well. We have Ping Identity, we have One Login, Jump Cloud, ForgeRock, RSA, One Identity, Oracle. So that's about the different products. Now, having said that, I will I will have a pause since my the thought is complete and I'm opening the floor for questions.
I'm audible.
Yes, sir.
So, what will be the process for having signed MOU with you? We would like
Sign with.
MOU. We would like to sign one MOU with you. So, what will be
Okay.
the exact process for that particular thing?
What is the MOU, sir?
Memorandum of understanding.
Yeah. So for the sale point product you're talking about, or the in general cybersecurity?
Because I'm the group director of the one engineering college in India. So
Okay.
I'm interested to explore some, you can say, the engineering skills of a student in this particular field.
Sure. So what we can do, sir, we can have the setup on your local machines of the students or in your lab, sell point product. I do have videos for that. Once you set up the sell point product into your lab, you can start the practical on that one. And I was ex-employee for EY. and then I was an ex-employee for KPMG as a contractor, and then I was 10 years with the JP Morgan Chase Bank. So these are the big companies are using the SailPoint tool, and trust me, your all student have a very big job openings in the market for the big fours. If your student explore on this one, I'm happy to again connect with you, and then I can explain you as well on the SailPoint. I can introduce with the SailPoint account manager, who has the product or vendor. They are internationally, they have India as well branch, and then US branch as well. We can happy to connect with you and explore on that one as well. But we do have a lot of the if you go to the multiple platforms, or like for example Udemy, there is a lot of videos are available, self-learning videos are available. But yes, I'm open to give you the another video where how to install the SailPoint and how does your student can make a practice on that one. Yeah, we can collaborate.
Definitely. Thank you. I will be happy to sign the same thing
Sure,
with.
sure.
Test, test. Can you hear me?
Yes, I can hear you.
Okay. My name is Herika. I'm from Universitas Yarsi, Jakarta, Indonesia. Is there any programming skill or ability that the student have must to explore or to deploy the SailPoint?
Yes.
Yeah.
So SailPoint product is SailPoint product is based out of Java. Java programming is basic Java programming. Students should know about it. It's
Okay.
it's about the Java programming. Product is based out of Java,
Okay. Thank you.
and you can visit Harika on community.sailpoint.com and then documentation.sailpoint.com, where a lot of coding parts are available
Okay. Thank you, sir.
anytime.
Is there any question? Okay, good. Please give applause to Mr. Busan Chavan. Thank you, Mr. Busan Chavan, for your insightful notes in cybersecurity. It's really opened our view. Thank you.
Thank you so much. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. And now we move to Mr. Rakesh Pai from Evicor Healthcare, Cigna Healthcare Group, USA.
He's not available.
Pardon me?
He is not available now. So
Oh, not available. Okay. We move to Dr. Manmohan Sukla, Group Director, Pravin Singh Institute of Technology, Kanpur, India. Please, sir, the podium is yours.
Thank you. Please open my PPT. Yes. We can move? No? It will be functional? It is functional? No? It is
Up
power.
and down and pointer.
Up. This one is down. Yeah. Okay, thank you. Good morning. So today I would like to discuss some important points related how AI will contribute in identifying the skin cancer. And when we are discussing this particular thing with the help of the AI, So the most important thing is how we can classify and then identify and then prediction. And this particular thing is very much beneficial in identifying the skin cancer at the very early stage. So basically my discussion, you can say this lecture, this session will be categorized in 5 different ways. One is introduction, second, how artificial intelligence and again at the same time deep learning model will illustrate the identification of the skin cancer. And third one is that the technical aspect, vision transformers. And then how do we analyze, and then we will discuss how we can identify the skin cancer at the early stage, and what will be the future scope of my model. So skin cancer is basically one disease which is not only nowadays found in India, but also in the rest of the world also. And there are more than 1 million cases of the melanoma per year in India. So we studied primarily cases in India. On the basis of that, I have my team has decided to work on this. Team of the 15 people is working on this particular thing. Early detection of skin cancer through accurate classification of skin lesions is essential for effective treatment, and this particular thing is well aware to each and everyone. If we can identify skin cancer at early stage, then it's very easy, it's very convenient to, you can say, cure that disease. And SE happens, skin cancer happens when skin cells are damaged. Important point, what basically motivated us to work in this particular field, that we have analyzed, we have studied this thing, that skin cancer basically happens in that case when skin cells are damaged. And it is very difficult to identify the phase when these cells are basically damaged. If any way we can find the methodology, if we can find any, formulate any model that can having the capability to find at the early stage, then it will be you can say convenient, comfortable for each and everyone to identify whether the skin cancer is there or not. Frequently due to the exposure to much UV radiations from the sun or training beds. So it is the conclusion of the first study, that is these cells are basically damaged just because of 2 important facts. One is that is the UV radiation from the sun, and then the tanning beds. Skin cancer is a condition where the cells in the skin start to grow in an abnormal way and for a limb or tumor. It's you can say the result of the primary study. It is often caused by exposure to sunlight. I have already discussed, I had a detailed discussion on this particular thing. Primarily the skin cancer is basically just because of this fact, because skin cells are basically damaged just because of the UV rays, which are basically experienced by sun only. To reduce the risk of developing skin cancer, it's very important to protect your skin from sun, avoid tanning beds, and regularly. I already discussed this particular thing. The majority of the cause behind the skin cancer is basically the UV radiations, which are basically explode from the sun. So it's important to understand that we need to protect our body, we need to protect our skin from this kind of the radiation, which are basically coming from sun. Check your skin for any changes or abnormalities. It's a first point we need to cater, we need to take care of this aspect. If the color, or you can say we are found this particular thing, that is fungus on the skin, that may be the starting of the skin cancer, we need to take care of this aspect. And it is the hybrid CNN convolutional neural network model with transfer learning for skin cancer disease detection in medical and biological engineering computing. And it's my research paper which is published last year, and which basically illustrated how we can easily identify skin cancer and what are the different reasons for skin cancer. And it is by the well accepted by the audience from the global platform. So we can easily understand this benign, these cells are damaged at early stage. With the help of this model, we can easily identify the damaged cell at the early stage. It is common on fair skin and can be found anywhere on the body. Sometimes we are thinking in this way that we don't have this kind of the problem, and our body, our cells are basically looking in this way that we don't have this problem. But sometimes the fair skin may also have the damaged cell, and in that case only, sometimes damaged cells can be identified quite easily. Sometimes it's very difficult to find a damaged cell. So in that case, when damaged cell can identify easily, then there is no problem to identify whether there is a skin cancer or not. But in some cases, when the damaged cell are basically, it's very difficult to find. In that case of skin cancer is very crucial. And this study is very much beneficial in that case. So it's very common on fair skin and can be found anywhere on the body. The model is using hybrid CNN architectures to classify skin lesions in melamine and benign classes. So important thing is this particular study, this particular model is based on the convolutional neural network, and it is hybrid, means that can we have used the one thing, that is the artificial intelligence in you can say the complex domain. That is not on the real domain, that is on the complex domain. The hybrid model consists of CNN and machine learning. How AI can contribute in this field, how AI can contribute in this research area, that's very important. So AI models, methods have significantly improved the automation of skin lesions classification in recent years. So three important aspects that we need to discuss. One is deep learning, CNN models. Second one is vision transformers. And last one, that is generative AI. From last 1 year, plenty of the work has been done in this particular field with the help of generative AI. So first important point, that is machine learning techniques are those algorithms which are capable of learning the interrelated correlation in data and take decisions accordingly without depending upon unequivocal instruction. And it is very much important, it's quite familiar fact regarding the machine learning. That is, the machine learning is one technology which basically need to train the machine on the basis of the data. It means we need to train the data set, and we can get the data, we can get the outcome as per our requirement on the basis of that trained data set. So a deep learning model called a hybrid convolutional neural network combines the benefits of convolutional neural network and conventional neural networks. And this one is a very crucial point in this study. One, that is the CNN is basically the one kind of the deep learning. And this particular thing is basically having the essence of both the things. That is one convolutional neural network, and second one is conventional neural network too. So this is the model on that is basically generated. You can see the worked by my team. That is the simple one. That is we are having the input and output, two things, and in between that is the we can say the convolutional neural network. Rectify linear unit is the one part, and then input and pooling layer also. So in this way, we can understand two important points, that is forward propagation, and second one is the backward propagation. It means sometimes we are getting the adequate result, but at the same time, sometimes we are not getting the adequate result. In that case, we need to reverse the engineering process, and that particular thing is basically known as backward propagation. Now, we need to understand how deep learning model can contribute in this field. And that is hybrid CNN is then comprehensively evaluated in the image classification and retrieval task on different data sets. So when this particular model is basically working on the different data set, then we found the better output, you can see the results when we have worked with the help of the hybrid CNN. Hybrid CNN models the creation and validation of deep learning based diseases screening system that classifies the images as having the abnormality or not using a multitask network helped by the transfer learning and ensemble learning is used. So in this way, we have basically taken the images of different parts of the body, and then we have trained that image with the help of the available data set. We found that there is a big difference between the mechanism. So we have tried to fill that particular gap with the help of the hybrid CNN model. Skin cancer detection with hybrid CNN model. So now it's time to understand how we can detect skin cancer with the help of hybrid CNN model. So CNN architecture have been used for the feature extraction. So in general, we are generally using CNN model for the feature extraction. Once the feature have been extracted, we need to understand these feature may be termed as the data, and we need to train this data set so that we can use these feature, these images for the identification, exact identification of the skin cancer, whether there is a skin cancer or not. Machine learning algorithms have been used for the classification. So we are using two things. One, CNN architecture, and second, machine learning algorithms. So we need to understand what is the exact role of these two different things. So I have already explored this particular thing. I have already discussed this thing. That is, CNN architects are used for the feature extraction, and the machine learning algorithms is generally using for the classification. So once we have feature have been extracted, now it's time to classify. I have already discussed this particular thing. We need to classify whether there is a skin cancer or not. And if there is a skin cancer, then we need to understand the sincerity, you can say the gravity of the skin cancer, whether the skin cancer is at the primary stage, or you can say the last stage. And this is the HCTL model, which is basically well known in case of the, you can say, the convolutional neural network. So that is the pre-processing, then feature extraction using CNN, and the most important thing, random forest classifier. The important thing is in this diagram, in this model, that is the random forest classifier for the classification. So on the basis of this particular thing, we can easily classify the, you can say, the skin cancer disease. The important thing is this is the original data set, and that is the testing data set. And on the basis of this particular thing, we are trying to test whether the original data is basically used for the evaluation or not. And the working process of the proposed HCTL model, and this is the, we have used VGG16, VGG19, and other convolutional neural network model also for this particular thing. And what is the advantage? With the help of the deep learning, we got one important point. We got the one important, you can say, the outcome result, and that is improved accuracy in classification. if we are not using this thing, I have observed this particular thing, it's very difficult to classify the problem. With the help of the classification, we can easily identify skin cancer at the very early stage. And that's why improvement in the accuracy for finding the classification is very much required in this field, and that can be easily achieved with the help of the deep learning. Potential for the early detection, I have already discussed. And then reduced need for the human intervention is obviously because at the primary stage, there is a need of the various types of the, you can say the various kinds of the testing and various kinds of the physiotherapy like the thing. But with the help of this model, human intervention is less required. Potential for personalized treatment, sometimes if we have observed this thing, with the help of the 100 different images, 100 different skin cancer cases, some are the identical in nature and some are distinct in nature. And most important point is when there are the identical, you can say the similarity in 100 cases, then it's very difficult to identify, it's very difficult to set the specific treatment for the specific patient. So with the help of this particular concept, we can fix this thing, we can ensure the potential for the personalized treatment. And now we need to understand how it is possible. And we have taken the two different kinds of the data set, and we have taken data set of total 13,902 images. Out of these images, 11,121 images for training and remaining images for the testing. And two aspects are important. One is training and second testing. So we need to understand how many images are basically have been used for the training and how many images have been used for the testing. So however, we also evaluated data set of different ratio as 70 to 30, 80 to 20, and 90 to 10. It is the international standard actually. Initially, we need to set the data for the training and the remaining data for the testing. So initially, we have set this bar, this benchmark that is 70 to 30, and remaining that is 80 to 20, and subsequently 90 to 10. And these are the results, and that is basically the very, you can say the fantastic result, which basically motivate us to work more and more in this field. This result, initially it was 94.3, then accuracy is 94.1, and finally we got the accuracy 95.82, proposed VIT at the 100 aspects. Conclusion. We have used efficient net, that it is the convolutional neural network, alongside other CNN model for feature extraction, and then extracted features are fed into a random forest classifier. I have already discussed this thing, with 128 N channels, which are able to classify the feature as malignant or benign. The accuracy achieved by the hybrid model is 90.11%, and the accuracy achieved by the LVIT is 95.82%, and which is basically higher than the previous one. Future scope. And two important points there, first and third point. Two important point is very much relevant, very much having the significance in this context. One, federated learning for privacy, preserving or without sharing data analysis completion. It is very much important. And second point is not so much important, but third point is very important. Multimodal learning, generative AI, LLM models are required. So nowadays, this particular system, this particular model can improve further with the help of the generative AI. And most obviously, that is the explainable AI for transparency and trustworthiness. Quantum ML, quantum convolutional neural network for scalability and large data set. Nowadays, everybody is working with the help of the quantum AI, quantum machine learning. So obviously, for this particular thing, there is a big scope of using quantum machine learning. We have chosen, you can select it, we have worked on these different research paper. We have basically analyzed these research papers, we have derivated many important facts from these papers. Thank you. The important point is the future depends on what we do in the present. And this important quote is of Mahatma Gandhi is basically the base of the different research learning. We can take the example of the AI, now it is generative AI. And when generative AI is basically evolved, that is the base, the base for that particular thing is the artificial intelligence only. Thank you very much.
Thank you. Thank you. Any question?
Thank you, sir. It's very interesting. Actually, we also have many research on health informatics, and we also working on. I think one of our colleague in our faculty member also work on skin cancer, but now actually we work on cervical.
Cervical.
Yes,
Cervical.
cervical cancer. And in ERC, we work with hospitals, many hospitals in Jakarta. So I think in the future, maybe we can collaborate more.
Definitely,
Yes,
definitely,
because
definitely.
we try to use AI. And I read that you also mentioned about LLM,
Yes,
double LM.
large
So
model.
what do you mean by, do you mean like ChatGPT so people can send the picture,
Yes, yes.
something like that?
Uh-huh. But this particular model is basically not like that actually. So we just take a photograph from our mobile phone. And we need to just save that that image into your system, in our system initially, and system is going to decide whether there is a chances of skin cancer or not in a few seconds only. So that is the almost same, but having the different technology.
So LLM is the like front end for the system.
Yes.
Oh, okay, thank you.
Okay. Thank you. Thank you.
Dr. Arthur has one question.
Any other question? No other question? From the audience online maybe?
Fine. Thank you. Thank you.
Okay, thank you, Dr. Manmohan Sukla. Very interesting research.
And his research is also aligned with your Center of Excellence. Where
Yes,
you are working
exactly.
in AI in cybersecurity. So you can appoint him as an honorary researcher in that center.
Yes, even deep learning. Now
Yes.
it's time of the deep learning actually, not the AI. AI was at the early stage. It is basically you can say the beneficial, but now it is the efficient deep learning model are there, and we are working on these models actually. So with the help of deep learning model, we can work. You can say the good work in this particular field. So we need to generally we are using the word artificial intelligence, but from my point of view, so it's a time to specify. Because AI is the buzzword nowadays, and AI is a big family. But when we are basically focusing, you can say the narrowing our vision at one particular point. So we observe this thing. Deep learning is very much beneficial for this particular thing. And from my point of view, next 5 to 10 years, the research in computer science is primarily based on the deep learning only. When we are talking the artificial intelligence field. So we need to collaborate with especially in case of the skin cancer. So there is one is standard data set, and second one is you can say the runtime data set. So for that particular thing, there is a need of the collaboration with the different hospitals also. So they are basically providing the data set.
So how long you train the data? Because we also work on ICU data, and using our own infrastructure, we need more than 40 hours to train the data. That's why we use Japanese infrastructure,
Yes,
and we only need 10 minutes.
Yes.
That's why I want to know how long you train the data. Your data.
So that sometimes that require the 10 minutes because that is depends on the, you can say, the efficiency of the machine only. So we are having the heavy machines and which they are basically capable to train the data set in the 10 minutes only. Okay, so we are working with the IT Kanpur, the collaboration with the IT Kanpur, and there's a huge center of artificial intelligence over there, and we have the collaboration in this particular field.
Hey, thank you.
Dr. Manmohan sir, thank you so much for your CNN model. And I'm very excited to tell you that I was working on the same direction, but you're working in healthcare and I'm working into the cybersecurity. So I have used this CNN model for one of the biggest cybersecurity conference in Silicon Valley yesterday itself. And we use the CNN model. I'll quickly showcase, if you don't mind, I'll quickly showcase the how the CNN model work into the cybersecurity. I will just run it. So this CNN model we use in the Python language, and what we are trying to do here is whatever the website is having click checking attack, we are trying to identify with the CNN model. And if you see here, this is the recorded video. I have given the URL, and then it is checking that particular website or URL is malicious or it is safe to hit it. And I'm proposing this to the Microsoft that if they can use this module in terms of as an extension to the browser, whatever the you are hitting that website is safe or malicious. So I'm very excited to learn from you again in the future. But I'm working on the same direction in the CNM.
That's nice to hear this thing from your side. And there are the other deep learning model are there, which are basically, you can say, the more capable to do the same thing. So we can discuss this thing further.
Sure, sir. I love your presentation. Yes, I want to more collaborate. This is CNN. We use the CNN model for this one, but I would happy to again learn from you and collaborate more. Thank you so much, sir.
Thank you. Thank you.
Thank you. Thank you again, Dr. Manmohan Sukla. Unfortunately, Mr. Rakas Pai cannot join us today, but we have another keynote speaker, Miss Nandini Giri from Microsoft USA. Okay, is it right? Miss Nandita, Miss Nandita Giri.
Hey, hi. Can you hear me?
Yes, the screen is yours.
Yeah. Just give me 2 minutes.
Oh, Miss Nandita, can you open your video, please? Your camera? Yes.
Can you see me? Okay.
Yes.
Okay. So I think I'll just go without slides if that is fine.
Yes, it's fine.
Okay, sure. So I just want to start by talking about agentic AI. So right now I work at Microsoft. I have been at Amazon and Meta earlier. So recently I've seen a drastic shift into agentic AI, like previously, like the same amount of work which we'll do in 1 month, we are actually able to do it in 1 week, even 1 day. And this has been possible only by AI agents and some co-pilots, which are like the support. Which are like the supportive co-developer we have right now. Okay. So what I can say is like AI has evolved from passive responders to autonomous agents capable of planning, executing, and learning. And it combines LLM with tools and memory, enabling goal-driven execution without explicit step-by-step instruction. So this shift is powering the next wave of enterprise automation. So which we are doing, where we are moving beyond chatbots and into decision-making and process orchestration. So I think LLM for understanding, generating, and summarizing, and planner, like it decides what steps to take. And then we have tools which can create APIs, database, and search engines. Example of that is Copilot, GitHub Copilot, which we use in our day-to-day. Daily we use it to write code. I think it's been a while that we actually write code. It's written by Copilot. We just have to review it. So I want to talk about one use case where we automated workflows like lead assignment in Salesforce and generating status reports. So right now, like all the workflows of the lead generation, when I say lead generation, it's like previously there was a human who would actually send a mail to a perspective, like maybe a possible lead, and then there'll be an exchange of emails, and then there'll be a probable sale of some product, let's say LinkedIn. Right now, it is being automated through AI and everything is being handled. There are some exceptions, like where AI is not being handled, then we hand off to actual human. But this is how the workflow has been created. Now there are AI assistants that respond to internal queries, reducing human effort. Like if you want to debug something, this has been very efficiently done by agentic AI right now. Like it actually debugs in 5 minutes. Earlier, it would take like entire team to debug at least 1 hour or maybe a full day. So this has been really, really good. Now, another use case which I have seen in Microsoft or like other companies, like Document AI, summarizing legal documents and extracting red flags. So there has always been a possibility of overlooking some red flags in legal documents. With this thing, we have reduced that to an extent. Now, this is not only limited to just writing code. Microsoft Copilot has been connected to Outlook, Excel, SharePoint, and it has been expanding. There are plans to expand it to whatever Microsoft has, or to actually make it reachable to every end user who does not even know how to code. So I think my take is that enterprises will move from AI enhanced to AI first operations, where we will be just reviewing what they are doing, or maybe you can say as a co-worker, AI and human can both together work efficiently is what I'm seeing. And companies are investing in multi-agent frameworks tailored to their business logic. Also agent. So one thing which in my experience, which is lacking right now is agent reliability, debugging, and autonomy versus control deficits, trade-offs. So I think that will define the next 3-5 years, because debugging AI agents is really hard, and there is scope of improvement there or research. And also like the autonomy versus control trade-off, which I say about like, is it ethical or not? I think these 3 topics, I think, will define the future. Think that's it. I think something like standard protocols for trust, agent safety, and observability are in the works. For example, AutoGen and LangChain Crew AI, which we use. And yeah, I think we should. Any questions on real world deployments, frameworks, or anything specific to AI agent, I can take it.
Any question? Thank you, Miss Nandita Giri.
Okay, thank you.
Nandita, one question from my side. So
Mhm.
what is the future for like agentic AI versus the previous version of the AI, right? Because it's going very rapidly fast into the market, right? So do you think it will be go one step ahead than uh, okay, let me rephrase my question. Like we just recently evaluated the company called as a cursor.ai, which will do the lot of coding, and I
Mhm.
heard that you explained that Copilot. So what is the toughest the product in your perspective? Because I work with NVIDIA closely, and they evaluated almost, I think, 50 plus tools, and then out of that, cursor.ai, they choose the first product into the NVIDIA to select for the coding purpose. So Microsoft is leaning for the Copilot only, or they support to the competitor like Cursor.ai, other product companies.
I think the plan is to improve or like um, improve Copilot or maybe have some functionality like Cursor.ai. I'm not sure if they are planning to invest on something like a competitor, but company is actually very invested in improving its AI. I think everyone knows there's a separate
Right.
company within Microsoft itself, which is like Microsoft AI. So they are working on self-improving agent ecosystems. I think that is the future, I'll say. That
Got
AI
it.
agents will collaborate, they'll learn from the outcomes and execute entire workflows from minimal human involvement. So it was excellent, the past AI, but at narrow tasks like maybe spam detection, language translation, or playing chess, if it is rule based, I think they were able to do it. It was able to do it perfectly. But I think I think the future is about self-improving agents ecosystems.
Thank you, Nandita.
And just to add on that, Cursor is part of Claude, which is under Anthropic, which is a direct competitor to what
Yeah.
OpenAI is. So it cannot acquire Cursor as such. It's a direct competition to what Copilot is.
Correct. So that's why, Ajay, like we as a developer or end user, we got confused, or we are just trying to understand, okay, what is the best product for me? Like, should I go for Cursor? Should I go for Copilot? It's all the time ambiguity to use the AI product as agentic AI. So
Mhm.
I have reduced my workforce by 20 team members when I moved to the cursor.ai, and we are leveraging that 20 peoples into the other activity. That's a different story. We are not doing headcount less, but we are going to be more productive, and then we surpass almost 500 million onto the project. So that was the dilemma all the time, like cursor or copilot, cursor or copilot. But
So
I think
for us,
Nandita is
we as an outsider of Microsoft, we use both Copilot and Cursor in our company. We started with Copilot, but then Cursor came up with all these MCP servers, integration with Zira and other products that we
right.
use. So for us, in our ecosystem, the more number of MCP servers that are available on an agent, the better the tool is. So for you, if SailPoint is integrated with an MCP on Cursor, I would
Yeah.
prefer going to that, so rather
Yeah.
than going to a Copilot. I'm just
Correct.
quoting an example over there. So it all depends
Yeah.
on what kind of products you use and how they integrate with the agentic ecosystem that particular product is providing you.
Yes,
Yeah,
right.
right.
I think, yeah.
So Bhushan, like
Thank you.
what did you decide then? Like I think you said, right, you were evaluating.
Yeah, so we evaluated almost 50 plus product, and then we finally, okay, it's not only me, NVIDIA also, one of my very close
Mhm.
friend work in NVIDIA. He's the top scientist in NVIDIA, and then they disclose after 4 years of the evaluation, after 50 products, they declared Cursor.ai to use it in NVIDIA. And we follow them, and then we use as well Cursor.ai. The problem is Java versus the Microsoft technologist, I believe. So
Yeah,
where I think Cursor.ai is heading on the Java direction.
got
Means
it.
more
Okay,
useful in the Java products.
got it.
But
Okay.
Copilot is not really bad as well. Like I do have Python in homegrown tool as well, which we built it.
Mhm.
And then we use Python, and for Python we use for Cursor. Sorry, Copilot.
Right, right. I think there might be plans like to improve Copilot to support all the other languages as well. So I think let's hope for
But
that.
yeah. Thank you, Ajay, and thank you, Nanita. It was good discussion. Thank you so much.
Thank you.
Okay, thank you. Thank you to our distinguished keynote speakers for the inspiring and presentation full of valuable insight. Before we proceed to paper presentation, we have, as a token to our appreciation, we would now like to invite Bu Umi to present plaque of appreciation and souvenirs to our keynote speakers. It is unfortunate that Mr. Busan Chavan and Ms. Nandita could not be with us today. Please, Mr. Manmohan. Yeah, Bu Umi will. Bu Umi, yes. Mr. Busan Chavan and Ms. Nandita, we hope to see you in person at future events. Once again, let's give a warm round of applause to our keynote speakers. And now I will ask Dr. Arthur James Swart from Central University of Technology, South Africa, and Dr. Biswajit Kumar Pandey to chair the session.
Terima kasih. We had a number of faces and they've all disappeared. 1, 2, 3, gone. But at least we still have the faces on this side. Oh, very good, excellent. And we have some faces over there, and we have some faces at the back, and most probably we've got millions of faces online. We're not sure. Good. So we would like to move to the paper presentations now, and I think we're going to be looking at paper number 1. Professor Biswajit Pandey, isn't it? Yes, paper number 1. Is paper number 1 online? Is he not? Is he gone? Oh. Okay, and then paper number 37 is next, isn't it? Or 30, paper number 30. Where's number 30? Also gone. Missing in action. So, Professor Biswajit Pandey, which paper must we then go to? The one that's online. I'm not sure which is online. Mr. Ajay. Mr. Ajay. Mr. Ajay, are you online? Hello, welcome.
Yes, yes, sir.
Oh, excellent. There you go. We have someone to communicate with on the other side of the world. We look forward to your presentation, please. Thank you.
Okay, thank you. Thank you so much for your time. Uh, hey, I'm Ajay Tanikunda. I'm from United States, and today I'll be presenting a paper. Yeah, I'll be sharing my screen once. Hello, everyone. Thank you for providing us this opportunity to share some thoughts and analysis on our paper. Um, Today, myself, Ajay Tanikunda, and my colleague Dibakar Reddy Pedanti, we worked on this research paper, did some analysis, and provided our findings and proposals as part of this paper. So we are presenting you ethical and regulatory challenges that we face in an AI-driven financial risk management process today. In this paper, we analyzed what are the current trends and what are the challenges that we are facing and what can be a proposed future to overcome the issues that we are facing today. We'll explore about as how when AI transforms this financial risk management, like a decision making that happens around financial process, and how what are the different types of challenges that we're facing in that, and what kind of frameworks that we require, and what kind of collaboration that we require in order to avoid such challenges. So today, like our previous speakers were talking about, everything is revolving, or at least the tech world is revolving around with this new technology trends that are happening on AI. Having said that, this technology is quite old, and recently it is gaining traction around every single field that we are talking about. Just covered we just covered about what difference it is making in cancer research. We just covered about how agentic flows are working. So here at this point, we are talking about how the finances or financial industry is being impacted as part of this process. So major thing that we are talking today is about how this bias on historical data, how is causing issues with decision making on AI. What kind of transparency or accountability that we need to bring into this process is what we'll be talking about, and what data privacy means to this, and how we need to handle such issues that we face around this. So before jumping onto that, just to give a brief on what happens on financial world, I'm taking a use case or an example of a loan application or a card application kind of thing. What happens beneath it and where is AI involved is what I'm trying to present over here. So being a consumer, let's say I go to a bank and submit an application. There will be different processes that are involved in making a decision that I am eligible for a loan, such as user verification, the consumer verification, whether the documentation is accurate or not, whether there is risk involved, whether he is fraud, and then after all these decisions, there comes an outcome saying whether to give the loan or not to give the loan, or whether to give the loan to a certain amount, not to the complete amount. So these are different evaluations that happen. So this process involves a lot of manual verification till date, and we are slowly automating this process in financial industry where a lot of the documentation validation process is happening automatically, and then risk assessment is happening using ML algorithms. This ML algorithms in our company we are using for like last 15 years. And now we're adding a tagline saying we are also using AI, which is deep learning underneath. We know the risk of using ML or AI because the bloodline for all these processes is the data underneath. Without having clean or good data, our outcome will still be an issue. And there is always this risk of providing the wrong decision, denying a loan to a right person or approving a loan to a wrong person. Both will be bad for an institution or bad for the society as such. Um, now, now that we know the AI is playing a role in making decisions, I'm also presenting you the trend of AI usage in financial institutions. Currently, we are at around like 13 to 14 billion of AI usage in risk management, but it is projected to increase to 40 billion by 2033. In fact, it is growing at a faster pace than when this article is published, which is in 2024, end of 2024. So we may be seeing much bigger numbers than what I am projecting in this paper because it is changing by the day. So what are the challenges that we are specifically looking into at this point? We're talking about bias and discrimination. Like for example, in historic periods, like let's say 1920s, 1930s, 1970s, 1980s, we saw a certain segment of people or certain set of people who are belonging to a specific race being denied providing any housing or any loan or any opportunity to grow. And we saw this in almost every part of the world in one way or the other. Taking for an example of blacks being denied having housing in the same parts of where the whites are building their houses in US, which is a uh, known history, which is read in school books of kids. Now that we came over that crisis, hopefully we cleared that entire issue out of every part of United States. Still, the historical data still talks about this. In data points, we still see that these denials are written into it. So when AI or ML goes through the historical data, digs through this information, and takes race as a metric, this will cause issues for a future applicant who has nothing to do with what happened in the past. So that's a bias that we're talking about. Another example to quote here is Apple Card gender bias issue, where woman who's applying to an Apple Card is being provided um, a lower credit limit over the same male participant with similar um, credentials. So these are the examples that are causing concerns to use AI as a tool to make critical decisions in financial processes. And explanation to these biases is unavailable. In one of our previous presentations, one of the keynote speakers were also talking about explainable AI, which is still evolving. It's not there yet. It is still evolving, but it is a much needed direction in which we need to go in order to avoid or eliminate any such issues. We need to take higher accountability to these kind of decisions that are being derived out of AI today. So what regulatory landscape is around this risk process or AI usage in risk management systems is currently in place. So there is an AI Act that is proposed by EU that mandates transparency. This was proposed in 2021, and there are processes that are in place in EU which are much more stricter than what we have in US. And then there are multiple bodies in US which handle these separately, like SEC, CFPB, Federal Reserve, etc., which also handle some of these regulatory issues that we are currently talking about. So there are gaps across various other countries as well, which I don't go in deep because of the time constraint. But there are various countries which are still facing a similar issue across the board in order to accomplish or automate some of these processes. So we talked about Apple Card case study just now, like lower credit limits to the users. So the underwriting process is something that I explained previously, where once the application comes in, what kind of analysis that we do in order to come to a decision of providing a loan or providing a certain amount of loan to a particular user or denying a particular loan. Just Finance is one other case study where we have discrimination based on zip codes, or certain area of people are provided a biased decision making. Like, for example, there are areas like Beverly Hills. When you talk about it, it's a rich neighborhood, and we take a bias of it based on that zip code itself, which is natural human tendency. And there are people around those areas who are rich, and even the data reflects as such. And when majority talks about a specific bias, the minor case points will suffer consequences. That's the point that I'm trying to make. Yeah. So in the in core, we need to have these principles of fairness, accountability, transparency, robustness, and privacy. So these are FATRP principles that we need to understand in order to achieve more transparent process in place. So we analyzed having human in the loop systems for critical decision making and how that makes a difference. It plays a key role, especially when you're denying a loan, um, eh, where the particular individual is hopeful of getting help from the financial institutions. We are talking about significant consequences to the person who is applying for this. So there are mitigation processes, like there are tools that are evolving today, which are actually providing a much better framework. But this whole framework process is still in evolution stage, and financial institutions are slow in adapting to the new technologies, and hence it will take some amount of time to get to the point where we have a solid framework which can actually provide these kind of decisions. Here we're talking about different AI techniques that we are having currently, which are like neural nets or decision trees, anomaly detection, or RL agents, which are having different regulatory requirements that need to be enforced into them in order to follow a specific example that I'm providing here on fairness or transparency or accountability or robustness. Uh, so, so the recommendations that we provided as part of this process is to adapt to these principles that we proposed, have a human oversight and conduct AI audits every every now and then. And also, we also propose to have a close eye on what the data feed that goes into your AI systems, and how the outcome would be. And also on the privacy part, the data and the data feeds that are provided should be scrutinized and also should be controlled on every part of it. So I think the regulators should enforce explainability, and also should have more guidelines on how to use sandboxes to understand the decision making of AI. How to standardize this process is a key area to look into. There is a lot of scope of improvement still in this process, which is happening currently. We are actively involved in some of the key conferences that are happening around the world on specifically these areas. And definitely the policymakers are actively working with us on getting into the right direction on this process. There is a lot of potential to conclude on this topic. So there is a lot of potential of AI usage in finance, especially on ethical grounds. There is a lot of unfortunate events that happened in this world prior to us. There is a lot of unfortunate events that are happening even today, which we cannot ignore or cannot take it for granted that everyone is treated equally. That is not true. The real world is still very chaotic compared to what an ideal world an AI system thinks. So we should always take that into note and then provide decisions based on that. And how to implement that is what we are asking as a call to action. Across disciplinary collaboration across all the AI systems is what we are trying to propose in this process. And we provided a few guidelines and references to our work in this paper. And that's it from my side today. And if you have any questions, I'm happy to help.
Jay Tanikonda, that was a very good presentation on ethics, ladies and gentlemen. Ethics are very important key criteria today. Do we have any questions for our presenter, please? 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 No, come, ladies and gentlemen. This researcher has put in the work. Let's engage with him. Just make him feel at home. Where's the question, ladies and gentlemen? Oh, no, you're a poor audience. I'm sorry. Okay, Jay, may I ask you, the field of ethics is important in education, in many, well, across all fields, and I'm glad that you're creating awareness in AI. Would there be a UN sustainable goal that we can link to it?
Definitely, there should be a sustainable goal. But the area of focus should have that sustainable goal as such, because the way the AI systems are built today are based on feeding the existing information into it. The goal should be the information that is fed is controlled or should have a meaningful impact on what the future should be. One of the previous presenters were quoting a quote from Mahatma Gandhi. Future is what we do today. Like, that's what we need in AI as well. Future is defined by what we feed to the AI systems today. And that should be our goal to achieve cleaner environment for future.
Thank you for that response, AJ. Very good. We have a question. Now you're becoming a good audience.
Yes, I'm just curious. We use many AI, and you mentioned that AI for finance. Yes, I agree that it's very important. Do you think we can use AI for both to stock market? So we just sleep at home and then our AI twin, doing
There,
the stock market and give advantage for us.
trust me, there are. So I invest in US markets, um, and there are already active agents which are doing things for all the big market movers, and hopefully it will be available at some point to the broader public. But today it's in the big hands.
We can sleep then.
You can sleep with me, Dr. Thank you very much, AJ, Tanikonda. That was an excellent presentation. Ladies and gentlemen, can we give him a hand or applause?
Thank you.
But AJ, you're not allowed to go anywhere. Just hang five. Eh? So, ladies and gentlemen, we are scheduled to have tea now, but AJ has got a second presentation. So we'd just like to have him do that second presentation. Otherwise, he must wait 15 minutes and then, come back again. So I think we must let him do the presentation quickly. Well, not quickly. AJ, is that fine if you do your second presentation on architecting secure e-commerce systems?
Hey, actually, one of my other colleague is about to present it. I need to bring him in. So I need some time for this.
Okay, so then we take tea, and then right after tea, so let's say in 10 minutes time, your colleague will be ready to do the presentation?
Yes.
Excellent. So we're going to have tea now, ladies and gentlemen, and then in 10 minutes time, we'll catch up with AJ and his colleague again. Thank you very much.
Thank you.
Tea time. Ladies and gentlemen, you have to get up to come to the tea. The tea is not going to come to you. Stand up. Here we go. We will start at 1:15. Thank you, Ajay. Another 5 minutes, please. Another 5 minutes, please, and we can start. Another 5 minutes. online with us? Please tell us, is it Sudhakar or Zuba? Can you hear us online? Hello? Not exactly.
Actually, you're sounding quite away from the mic. We are barely hearing you.
Now put it a bit further away. Put it a bit further away.
Test. Can you hear us?
Yes, yes, we can hear you clearly.
No, I'll hold it there. Sudhakar or Suba? Who is online with us?
It's Sudhakar.
Sudhakar.
Yes.
Oh, welcome, Sudhakar. We can see you. Can you see us? Hello.
Yes, I can see.
Oh, good, excellent. So, ladies and gentlemen, we're moving to a paper number, I think it's paper number 48. And Sudhakar is going to speak to us on architecting secure e-commerce systems. And it's got to do with deep diving. I don't know if there's oceans. Is there oceans involved? Diving in the ocean? AI, blockchain, biometric fusion. Ooh, this fusion word. It's almost like integration of some sort, eh? Hopefully it's not nuclear fusion. Sudhakar, we look forward to your presentation. Please continue.
Thank you. Thank you. Hello all, my name is Sudhakar. I'm here to present our architecture paper based on e-commerce systems developed along with my co-authors, Ajay and Subbarao. We developed a proof of concept for e-commerce websites that uses AI, blockchain, and biometric fusion technology to deliver a system that prevents fraudulent transactions. Why do we need this? Imagine a situation where a user logs into e-commerce platform at 2 a.m. from a device that they've never used before, a purchase which is around like $2,000, a camera, let's say example, is shipped to a location they never visited. From technical standpoint, everything looks fine. Credentials matched, payment authorized, but from behavioral perspective, it's completely off. By the time the actual cardholder notices the unauthorized transaction, they're left with a filing claim and wondering if they'll ever get back their money back. If the resolution don't go their way, the result is more than just a financial loss for them. It's a loss of trust in the platform itself. So this is why today I'll be walking you through an architecture that brings together cutting edge technologies like the biometric authentication, deep learning, and blockchain infrastructure to create an intelligent software, which is real time, that prevents fraud for the scale and complexity of modern digital commerce. I will cover the backgrounds and motivation, and then let's look at why traditional fraud detection methods are failing, and then we'll look at some real world case studies, and I'll present our approach, and then we look at the metrics, evaluation, benefits, and then finally conclusion. So globally, online shopping has explosively grown in the last 5 years. In 2019, it was 3.5 trillion business, and in 2024, it's 6.3 trillion. It's almost double. And the projections are aiming at over $10 trillion business by 2030. It's a huge market. And in the last 5 years, a major driver for this acceleration was the COVID-19 pandemic, which pushed millions of consumers and businesses online almost overnight. For instance, like Amazon reported a 40% sales jump in the first year of pandemic alone. Along with this, we have seen a transformation in the delivery convenience. Major e-commerce companies are experimenting with drone delivery and ultra-fast shipping services. Some are promising delivery within 10 minutes. This digitization brings convenience, but it also opens forum for new attacks. Merchants globally estimate losing around 3% of their total revenue to fraud each year, and it is growing. Clearly, there is need for more intelligent fraud detection system that can keep up with the pace of innovation and evolving threats. So one of the common tactic the fraudster use is identity theft, which involves like stealing names, address, and credit card details to impersonate legitimate user transaction, although it is not authorized. Next is the phishing and scam websites. Like they design these fake websites to mimic legitimate e-commerce platform, tricking users into capturing these login credentials and payment information. So these are some of the schemes that fraudsters use to capture these user credentials. Let's look at the limitations of the traditional methods. What the current e-commerce, most of the e-commerce, they're not really advanced technologies. They use something like a rule-based mechanism. For example, like block any card which is a transaction having more than $1,000 or $5,000 as a limit. Within weeks, fraudsters they split some 5,000 orders, 5,000 worth of orders into 5 transactions of $1,000, or a spike detection filter that triggers hundreds of false positives during a Black Friday. That will affect the e-commerce website during their peak holiday seasons. So these rule-based systems are brittle and they are prone to high false positives. And some other mechanisms like stolen credit card information with identification data like a phone number, address, these are purchased by scammers on dark web. They target multiple e-commerce websites to conduct fraudulent transactions in burst. Manual investigation in these scenarios is not a possibility. These are the limitations of traditional methods. So what are the leading companies doing? Let's take a look at the real world case studies. PayPal 2019 incident, they had an outage and their LSTM based sequence model detection, it identified a suspicious pattern. Users suddenly transacting from low risk countries to high risk ones in rapid succession. This was a clear anomaly and their rule-based engine lagged behind even though their AI system can identify this threat. Because of AI identification, their threat was mitigated, but it was not completely controlled. This highlights the importance of real-time adaptive models, but leveraging the power of AI. I can go on giving an example of Alibaba research team that they used click streams to do a 2D visual representation by tracking the behavioral data into images. They used CNN to detect pattern typical to scripted bots. This resulted in 90% accuracy rate in identifying bot activity. And JP Morgan and they use graph neural networks. They run on Apache Spark clusters to verify transactions on thousands of accounts. Clearly, it's like using AI, leading companies are able to catch hold of or identify the real threats, but they're still lacking on combating these fraudulent transactions. So this brings to our approach. What are we doing? We offer a three-stage approach. One is multimodal biometrics. The second is AI inference layer, and third one is blockchain audit trail. In the multimodal biometrics, at the login page, we combine device native biometrics like Face ID and Touch ID using advanced liveness detection and based on a histogram of oriented gradients to identify if the micro expressions of the users. And this liveness check will block 100% of spoofing up attempts, including those using 3D printed masks. Not just this, we also monitor the keystroke dynamics, like the dwelling time, how much the user is trying to taking time to click a button, as well as the flight time, like the pointer movement entropy. We use this to determine if there is any standard deviation from the user behavior, regular user behavior. If we notice, we issue a re-authentication challenge. This is the first stage. The second stage is the AI inference layer, where this is the brain of our system, where deep learning models analyze user behavior and transactions in real time. We use autoencoder module trained on legitimate transaction patterns like the amount, merchant code, and time delta. If there is a behavioral anomaly identified, for example, like a user is trying to spend a $500 purchase at 2 a.m., but his typical spends are like $50 during the day, which is clearly an anomaly. And this reconstruction is captured by our encoder module. And we also use CNN LSTM pipelines to convert the recent transaction history into 2D matrix, time versus features, where the CNN uses the local burst activity to identify any suspicious activities, while the LSTM captures long-term behavioral context. We also use GAN, the generative adversarial networks, to train our models to give uh, basically to generate a synthesized fraud pattern. And this reduces our recall or fraudulent type identification by 15%. The last pillar is the blockchain audit trail. Every decision made by our system is cryptographically hashed and stored in a permissioned blockchain ledger. This includes biometric passes, anomaly scores, and smart contract decisions, ensuring full auditability without exposing raw personal identification information. What is the use of these smart contracts? We use these smart contracts to enforce business rules automatically. For example, if a user fails to re-authenticate twice, the contract locks the account and alerts the security team. When a new transaction is posted, the contract can preliminarily flag it and trigger off-chain analysis for more complex patterns. So in summary, by tying every transaction to a verifiable individual behavior and continuously monitoring their behavior like eye movement and pointer tracing, we make sure the credentials, uh, we make sure that high accuracy with a transaction goes through without compromising the user experience. This is our core approach. Let's look at the benchmarks, how we performed. To validate our architecture, we benchmarked it against Visa AI Guard, which is one of the leading commercial fraud prevention system in the industry. Here's the summary. Operational efficiency, one of our key goals was to lower the detection latency. While many commercial systems, including this, operate at 5-second delay, our system achieves end-to-end transaction confirmation in just 3 seconds. This is critical for real-time fraud detection without disrupting the user experience. Detection performance, we improved accuracy from 92% to 97%, successfully identifying sophisticated bot cluster attacks. This was previously bypassed by Visa's AI guard system. Latency breakdown. How did we how if I break down the 3-second end-to-end finality, here's how it looks. Biometric check is around 30 millisecond. We execute this on device, like leveraging the Apple's neural engine or hardware accelerated neural network chips on Android devices, like the Pixel Tensor or Samsung Neural Processing Unit, or for Android devices. They are pretty fast actually when checking these biometrics. The AI inference, this is the costliest in terms of the execution. This run on GPU-backed microservices, which is taking around like 1 second to 1.5 seconds. And the on-chain smart contract execution, which is taking around like 900 milliseconds. The total end-to-end latency is around 3 seconds, which is bearable. Scalability in high traffic situations, like there can be a question like how do you handle traffic spikes during like a holiday event like Black Friday. We use the microservice Kubernetes cluster to scale horizontally based on auto scaling, and we also use queue latency while maintaining the SLA compliance even at 5,000 transactions per second. Privacy and compliance. Our system is built with privacy by design. This principle leverages based on the blockchain decentralized approach. And the advantage is that this ensures global regulators like GDPRs and other regulatory regulations are not compromised. So what is the benefit of this system? First, it reduces account takeover by fraudulent schemes. Like we leverage biometric live detection and the AI inference to verify the fingerprint verification and digital pattern. And if we notice any anomalies, we re-authenticate, issue a re-authenticate, which is done using continuous authentication. This continuous authentication will help in identifying any session hijacking, and we issue like re-authentication challenge again, or alert the user in case of any authentication issues. The third one is unified prevention, like detection in one pipeline. Our architecture blends on-chain and off-chain intelligence. On-chain smart contracts essentially enforce simple business rules like blacklisting IPs and exceeding transaction threshold from a particular user, or high-risk geolocation. All of this are rule-based business rules. An off-chain model like identifying the patterns using deep learning and behavioral analysis. This is off-chain AI models. And what about the governance? Like we have built, basically we are leveraging the audit trails by the smart contracts and the blockchain. So we hash the user behavior and the transaction on a permissioned blockchain, and without sharing the user information, actual identification, this allows us to do auditability. So in conclusion, our multi-model fusion is, it provides stronger defense. Data-driven models outperform static rules, but a stronger fusion of multimodal definitely strengthens the fraud prevention by reducing the false positives. And our solution is privacy first, intelligence driven, and which combines the biometric confidence and user confidentiality. So this results in a resilient, scalable, and compliant fraud detection, fraud prevention system that evolves with the threat landscape. I would like to conclude my presentation here. Now I'll open for Q&A.
Excellent. Thank you, Sudhakar. It's fascinating how your multimodal system is able to mitigate fraudulent activities. I'm really fascinated, and I'm sure we have some questions. Questions from the audience, please, ladies and gentlemen, engage our researcher. Ladies and gentlemen, please, thank you. Just one question, that'll be lovely, please.
Hi, hello.
There's
Hi.
a question.
I would like to ask one
sorry,
question.
Sorry, that gentleman over there first.
Okay,
Sorry.
okay. Thank you for the presentation. I just want to ask one question about the legal issue lah. So I can see that the storing raw biometric data in on the chain is something like the legal concerns and the issue there. So how about your proposal to encounter this problem?
This is a thought through process actually. Like security compliance is one of the core aspect. So when we capture the user information, like the facial features or biometric sensors like fingerprint, they stay on device and they get computed cryptographically along with the purchase details like the location, merchant ID, and the transaction. All of this gets saved on a blockchain. So none of this is actually owned by a company. It is decentralized system, and part of the information stays within the device at the user hands. So none of the information is actually centrally stored. So this is this is how we are actually taking care of the data privacy issue.
Yes. I would like to ask one question. How CNN is basically helpful in this work? Because you have used the CNN concept, okay?
Right.
And even GN also.
Correct. So CNN basically, when we say biometric authentication, it is the user behavior as well as the facial features or biometric information. That two aspects are being fed to the CNN model. CNNs are very good in image recognition and identification. So one thing is these embeddings from the facial feature are computed against the user profile. If they match, then we're good. If not, another check happens on the behavioral pattern. This is where the LSTM comes in, which keeps the memory of the past transactions on how the user actually do the shopping, like how long he takes to place an order, and how long the items stay in the add to cart basket and not actually purchased. Sometimes we tend to add to the cart, wait for some time, and do the purchase by verifying like the price is right and all sorts of things. So this is where we use these CNN and LSTM to match the behavior features along with the actual facial and biometric sensor information.
So have you worked in the complex domain or the real domain only?
What do you mean by complex domain? Like, can you clarify that?
Means that is the 2D information and three-dimensional coordinate geometry, and generally the CNN model is basically the good in when we are working in the complex domain.
Right. So the facial information verification.
Please listen, because in current scenario, generally research is going in the complex domain only. Because before 2 year, 3 year, it was in real domain, but now it is CNN model is basically applying on the complex domain. That is complex, you can say the values, real plus complex domain. You got my question?
Yeah, I mean,
because
the
efficiency of the CNN model is basically better when we are working in complex domain.
Yeah, so we haven't actually leveraged the 3D information. We use 2D information. I mean, as the years passed, there is more advanced deep learning models. But yeah, for our experimentation, the POC we started like few years ago, and that was the state of the art model, and we used CNN for our facial recognition, which was actually 2D information.
Okay, thank you.
Thank you very much for that presentation and also for the audience questions. Thank you, ladies and gentlemen. May we give a round of applause? You may be excused.
Thank you.
Excused. Ladies and gentlemen, we want to move to paper 52. Is paper 52 online, Nazira?
Yes. Can you hear my voice?
Oh, we can hear you loud.
Right. Thank you.
Are you going to speak to us on enhancing malware defense?
So, okay. Right. Can you see my screen?
We can see your screen.
Right. Okay. Please excuse me. Okay. All right. Bismillahirrahmanirrahim. So, good afternoon, everyone. So, a very thank you for the chairperson for the lovely introduction of myself. All right. So, my name is Nazira binti Abdul Hamid. So, I am pleased to present our study for today entitled Enhancing Malware Defense in Windows OS through ethical malware development and agile-based simulation framework. So it's a quite long topic. Okay. We actually from Faculty of Informatics and Computing, University Sultan Zainal Abidin Terengganu, Malaysia. Right, so this is the table of content for today's presentations. I will begin with an introduction and conclude with some summary of the finding and also some future direction of this study. Right, so for introductions, Windows OS is as we know, is widely used and it's making it a top target for cyber attacks. While malware detection is studied, ethical simulation of malware behavior is still lacking. So it's limit our understanding of how real-world attacks. This study addressed the gap by we developed a non-malicious malware prototype using agile methodology. So this prototype has a Docker payload and an invention component, and it also tested in a secure virtual environments. So unlike real malware, our prototype does not harm data or any systems. So all tests were conducted in an isolated virtual machine to ensure ethical boundaries are strictly observed. So given the legal and ethical constraints surrounding malware creation, as you can see by in table 1 analysis of some of related words, we can see that most existing research emphasize on detection and mitigation rather than simulation. So, however, understanding how malware behave is vital for designing a robust defenses. Previous words, as in table 1, they examine stealth techniques or mutation, ransomware, and even machine learning. Yet, few offer ethical frameworks for simulation, so that motivate our study. So we go to the third section, which is we discuss about the methodology of our study. So we adopt agile methodology. The main reason because agile is well known for the adaptability and transparency. So as you can see on the slide, agile framework can be divided into generally five phases. So we begin with the phase 1, where we do the requirement gathering or definition, where we clearly establish what the project objective are. And then we go to the design phase, where we create supportable architecture that align with the research objective that has been stated in the first phase. And then we go to the third phase, which is development and testing. So here we design and develop and implemented core components, which is, as I said before, the dropper, the payload, and evasion technique, with continuous functionality verification. And after that, in the fourth phase, which is deployment and monitoring, we implemented those components in a very controlled test environment. And the last phase was the review process. So agile, I can conclude that agile methodology offer crucial flexibility for developing our malware simulation framework. Because during the simulation framework, this interactive approach allow us to adapt to any unexpected security challenges. And then we go a little bit deeper on the methodology. We begin with the framework. So the proposed framework model, a 5-stage malware infection process, as illustrated in the figure 1. So it is actually simulating how malware typically infiltrates a Windows system. So for our study, it begins with a phishing email containing a link that when the user click, it silently download an executable, or we call it as a .exe file to the target device. So what it do here, the dropper uses evasion technique to avoid detections, and it's actually designed to look legitimate. So it tricked the victims into running it. So once it executed, the payload activates and gain access to the system. So each phase was modeled to reflect how the real world tactics safely. Sorry. Right. Okay. So next, a little bit about dropper algorithm. All right. So dropper. So in our experiment, in our study, the dropper is actually use evasion techniques to avoid detection, and it's designed to look legitimate, right? So here, the main function of the dropper to deliver the payload to the victim's device safely without getting detected by any defense mechanism, for example, antivirus tools. So AES 128 encryption is used to obfuscate the payload within the dropper. And also the secret decryption key is also embedded in the dropper as a private byte variable. So when the payload is retrieved by the dropper as a byte stream and then decrypted before it can be executed. So and then the decrypted payload is written to a temporary executable file in the victim's device, which is then prepared for a stealthily launch while bypassing security controls. So how we did, one of the library that we use or the code that we use in invocation target deception to invoke methods indirectly. So it is actually effectively hiding this payload from signature-based detection system. I can say that by mimicking legitimate software behavior and also avoiding direct method call, the dropper bypasses common detection mechanisms such as firewall and also antivirus software. And then we can a little bit on the payload algorithm itself. So unlike real malware, for our study, we do non-destructive payload. So its purpose is to simulate destructive behavior. Basically to study how the system responds under stress without any causing any permanent damage. So the destructive action is what we did is we display JFrame and also we play audio. So what the payload did, they continuously spawns random position non-closable JFrames. So the GUI window remain on top, cannot be resized or closed, and are randomly positioned based on detected screen dimensions. So the effect of this payload, so it simulated overload CPU memory resources. So eventually it will degrading system performance until the machine crashes or it's manually shut down. Okay, so some of the results that we did, we scan the SKC in figure 2. So this is the result of the smart scan by scan guide in the presence of malware. So we can maybe the figure is not is kind of blurry, but what we can see, the malware is actually successfully bypass scans guard detection mechanism. So demonstrating the effectiveness of the encryption technique employed. So these results actually highlight potential vulnerability in commercial antivirus solution. And so we need for more sophisticated detection method. So while the malware evaded detection, it was designed to be non-destructive. We did this to be in non-destructive and was only tested in a controlled and isolated environment. And the second one, we did before we monitor the CPU usage before and after the execution of the malware in the payload. So we can see that initially usage was normal, no major processes was running, and then system performance appear stable. And after the malware activation, it's actually quickly flooded the screen, right, with the G-frames, making it nearly impossible for the to interact or to monitor the virtual machine. And within second, the CPU uses spike to 100%. So for the conclusion, we successfully developed and tested a non-destructive malware prototype and evaded detection and demonstrate system impact. Our study is not without limitation. Tests were restricted to virtual machine and single antivirus engine because of the time constraint and the funding. And so the payload was intentionally simplified to avoid ethical and security concern. And for the future works, what we would like to do, we want to focus on expanding tests across multiple antivirus platforms or integrating any machine learning for detection, and also adapting other frameworks such as Mac OS and Linux. Okay, so the framework is actually lays the groundwork for safer and more informed malware defense strategies. Right, so that's all for me. Thank you very much for your attention.
Thank you very much, Nazira, for that noteworthy presentation. I think many years ago there was a movie called Escape Plan. I don't know if you saw it. It was with Sylvester Stallone. He goes into a prison and he breaks out of the prison to show the weaknesses of the prison. Yeah. And here's something very similar that you're doing. You're creating a malware and you're testing whether the antivirus can pick it up. That's excellent. Good. Questions from the audience, please? Please, ladies and gentlemen, engage the presenter. Come, ladies and gentlemen, the presenter, the researcher did all the work. Just say hello to the presenter then. Come, ladies and gentlemen. Anybody would like to say hello to the presenter? There we go, thank you. I don't know if you heard the question. Try again, please.
Miss Nazira.
Nazira, are you there with us? You seem to be frozen in time. Oh, looks like she's already gone. Oh, I'm so sorry. You can ask me your question.
Why she choose encryption algorithm AES 126
EIS.
256.
What do you think, ladies and gentlemen? Why did she choose EAS? Any thoughts? No thoughts? Oh, sorry. I can't give you an answer either, but it's a good question. Okay, thank you, ladies and gentlemen. We want to then move on to paper number 50. It's number 53. Yes, 53. Is Abdullah online? Abdullah?
Yes, I'm here.
Oh, wonderful. Thank you. Abdullah is going to be speaking to us about a robust algorithm for identifying malicious IPs. Robust. Very strong word. Please, Abdullah, we look forward to your presentation.
Can you hear me properly?
Can we do what, sorry? We can see your presentation.
Can you hear me, my voice?
Yes, we can hear your voice.
Okay, first apologies. My current setup doesn't have the webcam. As I'm joining from desktop PC, I am fully present and attentive. So I don't not webcam, so I don't my face.
No problem. No problem. Please continue.
Okay. Good afternoon, everyone. My name is Abdullah Siam, and I'm here to present our research on a robust algorithm for identifying malicious IP, enhancing cybersecurity defense. This research was a collaborative effort with my colleague, with my teacher, Tuhid Buyan, MD Maruf Hassan, Nuruzzaman Faruqi, and Indamul Haq Sonet. We're excited to present our work at the 9th International Conference on Recent Trends in Computer Science and Engineering. Now, here is the presentation outline. First, introduction. Let's start with a quick overview of the problem. In today's cybersecurity landscape, threats like botnets, DOS attacks, and brute force attempts are on the rise. Identifying malicious IP addresses quickly is vital to securing network. Traditional manual IPsec are slow, inefficient, and unsuitable for high velocity environments like cybersecurity operation. So our solution is multi-source automated system that integrate threat intelligence from abuse IPBD and virus total to provide the real-time IP analysis. This system automates the IP classification as a good IP or a bad IP, allowing the cybersecurity teams to respond faster and more accurately. Next, problem statement. Now, let's look at the core problems we are addressing. First, real-time solution needed. SOC, Security Operations Center, require a system that integrates real-time threat intelligence to quickly classify the IP, it's good IP or it's bad IP, and delays in detection and response. Manual IPsec and static blacklist lead to delay, increasing the risk of the cyber attacks. The current solution, the static blacklist and manual checks are outdated, and it's very slow and it's very time consuming and fail to address the dynamic threat. And cyber attack growth, the increasing the sophistication of IP-based attacks like DOS, malware, and data breaches require faster, more efficient and detection system. So our research objective. Now our research objectives are clear. First, automated IP classification. We develop a system to automatically categorize IP address, it's good IP or it's bad IP. Then integrate the multiple data sources. Combine real-time threat data from abuse IPBD and virus total for the more accurate analysis. And other objective is enhance SOC efficiency. It reduces the need for manual checks and improve the overall response time in SOCs and food productive threat detection. The enable the quicker decision making, allowing the security analyst to the focus on more the critical tasks. Now, literature review. To frame our work, let's verify the review some related literature. Bloom filter used for efficient IP reputation queries, balancing speed and lawful positive. Then static blacklists, it's widely used but suffer from high false positive and fail to adapt to evolving threats. Then machine learning technique like random forest and clustering enhance the dynamic threat detection and to adapt to changing attack pattern. Then API-based solution, threat data like abuse, IPBD, and virus tutorial significantly improve the detection accuracy and reduce the false positive. So the research identify the gaps and including the need for the real-time integration of the multiple threat data sources. So here is our the methodology. Now let's dive into the methodology behind our algorithm. The IP reputation algorithm automate the classify the IP address. Here is an overview. Uh, First, in Inuma's number of requests in server. Then, security analyst how to check it's good IP or bad IP. First, security analyst one IP and in search in Google and web and they are searching it's good IP or bad IP. So it needs more time and time consuming. So I develop algorithm, just run the algorithm and put the IP and it's classified it's good or bad. How it's work? Let's take a closer look at how the algorithm works. First, input collection. The system collect and validate the IP addresses submitted by users. Then API integration. Each IP is required using abuse IPBD and virus tutorial to gather the threat intelligence data. Then scoring and evaluation. The system calculates and combines score by the weighting data from the both sources, abuse IPBD and virus total. And then it's classify, IPs are classified at good or bad based on the combined score and predefined threshold. Here is a flowchart how these algorithms work. As I described the previous slide, that first input collection, API integration, scoring and evaluation, lastly classifying the IP. Now let's now look at the result of our algorithm. We tested the system using dataset of 500 labeled IP addresses, half pagan and half malicious. The system achieved accuracy 94.6% and precision 93.7% and recall 95.6%. These results demonstrate that the system effectively distinguishes between the malicious and bliggling IP or good IP with low false positive and false negative rate. Our algorithm showed the strong performance in real-world testing. Uh, test results, IP addresses were classified based on combined threat score and from the abuse IPBD and the virus tutorial. And performance, the system is highly effective in quickly identifying malicious IPs, enabling the faster response time and reducing the manual workload for the SOC analyst. Now, challenge and future direction. Despite its strength, there are some challenges we need to address. First, API limitation. Rate limits on free API tiers can slow down the system's performance in high traffic environment. Then data freshness, the real-time threat intelligence relies on up-to-date reports and delays in trade data submission could leave the system vulnerable. And its third-party dependency, relying on the external service, introduce the risks like API downtime or changing the pricing the model. Now, in future work, we plan to explore the machine learning to make the system more adaptive to new threats and introduce continuous learning to enhance decision making. And last conclusion. In conclusion, this algorithm significantly enhance cybersecurity defense. Uh, Future potential, the system can be expanded with the machine learning to the continuously adapt to the evolving threat. Then scalability, the algorithm is scalable and the suitable for high traffic environment like SOC, a security operations center. Then impact on SOC. It reduce the manual checks and improve the response time, making it the valuable tool for SOC analysts. Like when we individual IP search to the web, and then individual check it's good IP or bad IP, we need more time. But this algorithm, we are improve the response time and making it the valuable for the SOC analyst. Then efficiency, the automated system streamline the IP classification process, enabling faster, more the accurate threat detection. So here is a reference.
Thank you very much, Abdullah. That was fascinating. I picked up the word Bloom filter. When I think of education, I think of Bloom's taxonomy. And I see you speak about IP, which of course is Internet Protocol, isn't it so? But in entrepreneurship, it is intellectual property. So it just shows how the context of the research paper should be very clear. But thank you for your presentation. I thoroughly enjoyed. Let's ask our audience for some questions, please. A question,
Yes,
thank you.
Thank you, Abdullah, for your presentation. I would like to ask about the scores. What the reference for the scores? You said there is two scores, abuse and I forgot the other one. And
Another is abuse IPBD and other was virus total. I used the two API in my algorithm.
What what the reason that you use the scores 60% and 40%?
It's like okay. It's scoring and evaluation. The abuse IP BD and 60% it the combined score. It likely that his system abuse IP BD has one database and this system that is known this IP reputation. It's good IP or bad IP. His own system it's the weighted mathematically. He identified that. This value, the 0.6 or 60%. Other is bias total, it's check the 40%. It's good IP or bad IP.
Okay, thank you.
Are you clear?
Yes, thank you.
Yes,
thank you for your response. Yes, excellent. Thank you, Abdullah. Thanks, Abdullah. You are excused. There's no more questions here. Thank you very much for your presentation.
Okay, thank you, everyone.
Ladies and gentlemen, we would like to move to number 63. Is Siti online? Siti? Oh, Siti is here. Okay. Siti would like to move to you. After Siti, we are going to move to paper 60, ladies and gentlemen, because 60 is online, but we're first going to go to Siti for her paper 63, Issues and Challenges in Ciphertext Policy. Ciphertext Policy. Siti, we look forward to your presentation. You're going to use the microphone. 63, yes, paper 63. I think this one, that one, they say makes too much noise.
Okay, Assalamualaikum and good morning. Morning, good afternoon. Okay, I will presenting my study on issue and challenge in cybertext policy attribute-based encryption for secure cloud storage. I am Dalila from University Sultan Zainal Abidin. Next. Okay, this is my outline for. Oh, okay. Alright. Okay, this is my outline for my presentations. I will start with introduction to CPABE and I will talk about issue. We have four issues: cybertext size, multi-authority architecture, user revocations, access policy, and I will conclude with the conclusions. All right. So, introduction to CPABE, CP Cybertext Policy Attribute-Based Encryptions and Cloud Security. As we know, the cloud storage system provides us a cost-effective and scalable solutions, even though it raises so much issues with data confidentialities. So while traditional encryptions method are commonly used to protect stored data, they fall short in supporting fine-grained access control. Additionally, cloud service provider may not always be fully trustworthy, posing further risk to sensitive data. All right. So this highlight the needs for the most robust mechanisms capable for securing information even in untrusted environment, and also that mechanism will provide access control, fine-grained access control. Okay, so the mechanism that have both that provide data confidentiality and also fine-grained access policy attribute-based encryptions. This CPABE address this gap by embedding access policy directly within the cybertext and enabling flexible and secure data sharing to the others. As such, CPABE plays a vital role in enhancing cloud storage security, making it essential to explore and overcome the challenge associated with its implementations. So this is the CPABE framework. We have the sender, the authority, the data user, and also the cloud service provider. Alright, so the sender will send the data along with its access policy, and then this access policy will embed with the encryptions mechanisms, and that cybertext will be uploaded to the cloud service, cloud storage, and then the user who have the right access policy, he or she will download that cybertext. Okay, this is the research methodology, the literature review that I studies start from 2015 to 2024. Then the database that I search is IEEE, ACM, and also Google Scholar. All right, the study focused on 4 issues: cybertext size, multi-authority, user revocation, and also access policy hiding. Okay, so the first issue is the cybertext size. When we combine the cybertext with access policy, the size of cybertext itself will grow. If we extend the access policy, it's affect the cybertext size. So this growth negatively impact the computational performance, storage requirements, and also network transmissions. To address the issues, several solutions has been proposed. The first one is constant size cybertext scheme to minimize resources usage. And also, when we consider the size, we also try to compress the message that we want to encrypt. Compression technique that exploit repetitive attribute set. The third one is threshold attribute-based encryption that enabling flexible attribute selections. So the second issue is multi-authority architecture. Multiple authorities collaborate to manage different attribute set, enhancing decentralization, fault tolerance, and also resilience in access control systems. This architecture avoid resilience on a single authority, but introduce several key challenges. Before we use multi-authority, we have a single authority. When we have single authority, if this single authority is down, so the encryption mechanisms cannot be done lah. So when we propose multi-authority architecture, it's introduce another issues which are collusion resistance, ensuring that malicious user or authorities cannot combine key to bypass policy. To mitigate this issue, researcher has proposed various solutions. Threshold-based key generation to improve security and prevent collusions. The second one is decentralized multi-authority, allowing any entity to issue key securely. And then the third one is lightweight multi-authority scheme for IoT, Internet of Things, such as RMA CPABE, which ties the ciphertext to domain authorities rather than attributes, improving that's method improve the scalability of CPABE. Then and the last one is multi-group supporting policy hidden scheme for dynamic 5G IoT scenarios using using attribute obfuscation and CRT based key management. So for the third issue, user revocations. User revocations is critical for maintaining data confidentiality and preventing unauthorized access in dynamic cloud environments. In certain cases, we need to revoke the user. So these user revocations give impact to the CPABE securities. So effective revocation required timely key updates and also access policy refresh, especially when user leave the system on their access right or their access right change. Several techniques have been proposed to manage these revocation issues. The first one is using attribute revocation list to track revoke attributes and restrict access. The second one is dynamic binary tree structure to enable scalable and fine-grained user revocations. The third one is traceability and also whiteboard revocation schemes using fixed point identifiers and key segmentation for threater detections. The third one is CPABE with access policy update, which support the dynamic policy modifications and along with revocations. The third one is, recent schemes in collaborative health system combine OBDO-based structure with identity-bound key to ensure forward and backward security. The latest one is the latest lightweight revocation mechanism for secured constrained device for IoT environment, use constant size user key and also eliminate the need for complex ciphertext updates. The number 4 issues is access policy hiding. When we choose our access policy, the access policy is actually in the plain text. So whoever intercept the transmission, he or she can read the ciphertext lah. he or she can read the access policy. So many researchers try to hide the access policy to add more security to the CPABE. For instance, in health record scenario, visible access policy may expose identifiable framework. For example, affiliation, SSN, medical conditions leading to privacy leakage. So to address the issues, researchers have proposed several policy hiding approaches. The first one proposed by Pyong and also Zhang, which they propose policy section and wildcard-based logic gate to mask attribute values in access formulas. The second one proposed by Yadav and also Jean use the composite order binary groups to embed access structure securely within the ciphertext. The third one is Bloom filter and fuzzy attribute positioning to fully hide policies while supporting efficient decryption in IoT setting. Searchable CPME introduced by Lee that incorporate the attribute revocation and also hidden access policy. The latest advancements such as RMA CPME introduced multi-authority access policy hiding, optimized for enable IoT that reduce the ciphertext size and also secure the access policy. The last work by MGPH-ABE integrates the policy obfuscations of questions, keyword search and also lightweight group key management for 5G enabled IoT environment, enhancing policy and scalabilities. So this nowadays many researchers have advanced the research by advanced the CPABE schemes. Right, so the recent advancement in CPABE focus on enhancing performance and also security in IoT and also fog computing. This scheme incorporated advanced features to improve practicality and also efficiency of CPABE. The first work is done by Chowdhury, reduce ciphertext size by decoupling from the number of attributes as seen in RMA CPABE. And many researchers also outsource the process of decryption, shifting the computations away from end user device to minimize the overhead. And also the constant size user keys to reduce storage demand and simplify the key management process. The child and also in 2024 proven resistant of two chosen. So the scheme that proposed by Chai is proven to the attacks, chosen ciphertext attacks, to ensure robustness. And then example schema include RMA, CPABE, FOCPH, which RMA CPABE is a lightweight multi-authority schemes that optimize for fog enable IoT. FOCPH CPABE designed for industrial Internet of Things that fully outsource the process of encryption or also the encryption and also decryptions. MGPH-ABE tailored for 5G enabled IoT to support multi-group environment, lightweight management using the Chinese reminder theorem and robust privacy features. So the conclusions, ciphertext policy attribute-based encryption, CPABE plays a vital role in ensuring secure and also fine-grained access control in cloud storage environment. Despite its potential, significant challenge persists in terms of scalability, efficient user revocations, and also access policy privacies. So addressing this issue required continuous innovation and refinement to make CPABE more practical and also adaptable to real-world application, especially in dynamic and resource-constrained environment. Research moving towards lightweight, scalable, and privacy-preserving solutions, and the future focus is to integrate framework with dynamic policy support. So this study is funded by University Sultan Zainal Abidin. Thank you.
Thank you, Siti, for that detailed review from 2013 to 2023. Papers, excellent, good. Now, come, ladies and gentlemen. Siti's come all the way from her university, or from where she is located, to be with us. You have to ask her a question. Come. Not allowed to let her go without a question. Come, ladies and gentlemen, help us. Bishwajit, yeah, there we go. Thank you, Bishwajit. There you go. Yeah, you must listen, Bishwajit. Right, Bishwajit, you got to ask Siti a question.
Yes, Siti is one of the best researchers I saw, and his presentation was very nice, and I appreciate it. And also my question, so you can extend this paper so we can try for some good transactions. So now it's okay, we'll go with some smallest Cooper General. But if you extend this research in a well manner by expanding your reference base and adding some methodology, then we can somehow try IEEE transaction also. And that will be the great achievement. Thank you so much.
Thank you, Siti. He didn't ask you a question, did he? No, he didn't ask a question. Okay, I'll ask a question. What motivated you to start this research? Why? Oh, excellent. It's a good motivation. Okay, Siri Kushri, do you have a question?
Yes.
Yes,
Thank you, Siti. This is a very comprehensive research.
Yes.
Very comprehensive research. I just want to ask, have you tried to, so this cheaper tax policy in the data owner, yes, not in the cloud provider, no, data owner. Have you implement or try this policy in your research?
Yeah. I have developed the systems and I encrypt the message using AES, and also I somehow embed that ciphertext policy with the ciphertext from the message that we encrypt at the first place. And then I calculate the size of ciphertext, and also to reduce the size, because the size is affected the performance of my system. To reduce the size, I do a method that we can compress the text itself. So I mean, before we encrypt the message, I compress it first.
Very good. Excellent. Thank you very much, Siti. You may be excused to sit down, but you're not allowed to go anywhere. All right, ladies and gentlemen, we want to move to paper 64. Is paper 64 online? Otherwise, we're going to go to number 60. 64 is, I think it's from Maruf. Maruf, are you online?
I am 64 paper author. Maruf sir cannot joining. Just I want to present.
Sorry, which paper ID are you?
64.
64, yes. Okay, on diabetes prediction.
Yes.
Yes, excellent. And then we'll go to number 60. So 64, please. We look forward to your presentation.
Yeah, sure.
Is it Manu Nur or is it Maruf or Tawheed?
I am Mamun Rashid. Alex.
Okay.
Alex.
Manumur Rashid. Excellent.
Yeah. I want to share my screen.
Yes, please continue.
Yeah, sure. At first, I was to clarify. I'm joining from my desktop. That's why I cannot enable my webcam.
No problem, no problem.
Yeah, thank you, thank you. This is Mamun Rashid Alex from Dhaka, Bangladesh.
We're not seeing your screen yet, sorry.
Just wait.
We see a small picture of you.
Can you hear?
Yeah, there we go. Excellent. Continue. We can see now.
Thank you. So I'm Mamun Rashid Alex from Dhaka, Bangladesh. Now I would like to present our research paper titled as Diabetes Prediction Use and Optimized Ensemble Techniques. Here is my content and slide outline. At first, begin with the background and motivation. According to the WHO, over 422 million people globally suffer from diabetes. Early detection is absolutely vital to prevent life-threatening complications that then machine learning offer great promise to automating and enhancing the diagnostic accuracy. So, however, the real challenge of class imbalance, high dimensional data, and interpretability of our model. So now our literature review focused on the recent approaches, ensemble model like random forest, XGBoost, and decision training. We noticed that although these methods show potential, many models were not validated throughoutly and lack of generalizability and offered limited clinical interpretability. We identified several key gaps, a lack of generalizable ensemble-based model, limited cross-validation, minimal use of robust overfitting due to imbalance classes, use data from specific region. So we posed few research questions. Can ensemble model effectively predict diabetes from large-scale clinical data? How to minimize class imbalance to improve minority class detection among random forest, decision tree, and XGBoost, which perform best under rigorous evaluation. So here is our research objective to mitigate class imbalance and enhance model interpretability, to build or develop an optimized ensemble prediction using random forest, decision tree, and XGBoost, and to fine-tune the model using grid search, cross-validation, and Bayesian optimization via Optuna method. So here is our contribution: a robust pre-processing pipeline including new derived features like non-smoker, active smoker, and former smoker, which use stratified scaffold cross-validation, is called scaffold CV, and comprehensive hyperparameter tuning, both grid search and Bayesian optimization. Now let's dive into the methodology. We develop our model in Kaggle-based environment, and we can see the configuration in the screen. We use diabetes prediction dataset from Kaggle, which contained 1 lakh with 9 individual records. And we also apply for pre-processing IQR, that's called interquartile range, outlier removal, feature engineering, which contain feature creation, correlation, class imbalance using SMOT, scaling, and encoding. We validated using 5-fold stratified cross-validation. And we can see our model architecture. Here is now look at the results. In table 1, we compare our model performance, and we can see our XGBoost outperformed with others, offering the best balance between accuracy and interpretability. And the confusion matrix showed the Bayesian tuning with SMOT significantly improved. In the table 2, we represent the few of sample predictions. And also we can see random forest and decision tree is closely performed, but decision tree is show better, lower generalized. Here is the visualization of the result, like confusion matrix and model performance, train validation and test data. So I would like to conclude with few of future works. We aim to test the model on multi-center clinical dataset because we are using a single dataset. And also incorporate with hypertension and diabetes specific analysis, and also to develop a lightweight model for real-time diagnosis or quantizations, and also cross dataset performance comparison with our existing used dataset. So here is a few reference, and thank you very much for your time and attention. And I am also happy to share my research work.
Thank you very much, Mananur, for that brief presentation that is very concise and to the point. Excellent. Thank you very much. Ladies and gentlemen, can you give him a round of applause, please? Thank you, Mananur. Please don't disappear. We have a question for you. Someone's going to ask a question here from the audience. I know someone is eager. Come, ladies and gentlemen, help us here with a question. Otherwise, I'm going to pick on somebody. Yes. Okay, I'm going to pick on somebody. There we go. You can ask a question. No question. Asking questions. No, don't be like that. Mananur, I would like to ask you, diabetes, do you think we will ever eradicate it?
Sorry, can you repeat?
Do you think we'll ever get rid of diabetes, or will it always be here with us?
Sorry, can you hear me?
Yes, I can hear you.
Yeah, sure.
So do you think, Mananur, that we will always have diabetes? Will it always be a problem here on Earth?
Yeah, this is a chronic metabolic disorder.
Sorry, just say again.
This is a chronic metabolic disorder, so I agree with you. That's yes.
It will always be with us.
Yes.
Okay, so we need to be able to predict, and we need to be able to assist people that are suffering from that. You agree?
Yeah, I agree.
Okay, so your research has much value. Thank you very much, Mananur, for sharing today. We appreciate.
Thank you.
You may be excused.
Thank you.
We are going to move now, ladies and gentlemen, to paper 60. We are running a bit over time. Please forgive us. We are moving to paper 60. Before we go to lunch, let me just quickly here online. Is paper number, let me just quickly see the paper number. Is paper number 65 online?
Yes.
Okay, we're going to get to you just after paper 60. Please don't go anywhere. Just hang 5 there, please. We're going to get to 65 after we've done 60. We're just going to 60 quickly. Please, ladies and gentlemen, bear with us. We're going to paper 60. The thought of paper 60 has got to do with traditional switch network technology. Is that correct, eh? Yes? And is it Bakar? No?
Yeah.
Yes.
Shahbani.
Yeah, I don't have a name here. I've just got the surname, Bakar.
Yes.
Okay. Please, we look forward to your presentation.
Okay. Can I have a slide, please? Well, the first slide. Okay, thank you. So thank you, everybody. So actually, I will present the the network technology, GPON and traditional. So my name is Shabani, and my friends. We need the data and we need the good infrastructure. So we need to think three things. Number one is the infrastructure for the university IT. Number one is the infrastructure. Number two is the application. Number three is the security. Okay. So before we go to the AI and the application, everything about the data warehouse and all those things, and we try to handle with the security, make sure that we need to have the good infrastructure. Otherwise, we cannot handle number two and number three. So this is the motivation that we need to discuss today. Okay, so we can see that in network technology right now, we have two types. One is the GPON, and number one, GPON is the gigabit passive optical network, something like the fiber to home. And number two, okay, can I have? So number two is the traditional network. Traditional network is something like we need to have the core switch. After that, the disty switch, access switch. After that, we have another one is we call it access point. Okay, so we need to have the decision how to handle this technology there. Okay, so basically, before we make the decision, so we need to choose the good technology for to implement in the for 40,000. You can see that the 40,000 user. Basically, our university they use a traditional. Traditional means what I mentioned just now. Start from the core switch until the access point. Okay, next. Can you go to the next slide? Okay, this is the GPON is the fiber optic technology, more in the fiber to home, something like that. Okay, but the traditional network is the Ethernet switch and cable to connect device and manage data traffic. Okay, next slide. Okay, this is the overview of the GPON. We can see the component of the GPON. They have the OLT, passive splitter, ONU. Okay, next. So GPON also have something like the segment there. So GPON, NG GPON, and SDN and SFV integration. So this is the evolution of the GPON. Next. Okay, this is a overview of traditional switch. Start from point-to-point architecture, SD device, and we can see the scalability and flexibility. Okay, next. So the compare analysis, throughput and delay, we can see the GPON throughputs, delay, traditional switch throughputs, and traditional switch delay. So this is something like the component that we need to compare. Okay, next. So basically, we have a lot of analysis there, but for this session, I just want to show that one graph only. Okay, so we can see that you can see that the red color here. This is the Ethernet. So for example, the Ethernet or the traditional for 1 kit. This one for the you can see the top gun Ethernet for 10 gigs. Okay, 10 gigabit per second. So you can see that the throughput is not changed. Okay, downstream and upstream. Okay, so we can see that this one maybe we can use for our data center. Okay, data center. But the problem now in our university we have two. One is the resident area and another one is a something like the operational area. So we can see that we want to test the GPON, the new technology. Is it suitable for the resident area? We have basically 35,000 students. So we have something 35 in the hostel there. So the data show that, you know, let's say we, normally we can see that one student in the house, maybe they have 6 students only in one house. So we can see that if you use the GPON technology, so we can, the user maybe 6, you can get the higher throughput there, okay? So actually I don't want to explain a lot here. We have a lot of analysis here. You can read in the paper there. So we need to have the good design to distribute the throughput there. Okay, next. So talking about the cost, we can see the initial deployment of GPON, of course, higher, but the investment, but reduced excessive cabling because it based on the we get based on the optical technology. So the operational GPON also they have the lower cost. You can imagine that if the access point internet, the cost is maybe 1,000 USD, but the GPON just maybe less than 100. You know the access point there. So maybe the security and long term. Next. So use case comparison, the future. GPON is point to multi-point. Traditional switch is the point-to-point. Bandwidth share, but the traditional is switch. The cost lower to large scale, and the traditional switch is lower to the small scale. Maintenance lower. Traditional switch is high. Application, that's why I can say the application GPON is suitable used for the hostel. Okay, hostel, the student area. But the traditional switch, maybe we can use in the data center and enterprise levels. Okay, next. So, as a conclusion, GPON for the large scale, switcher for the high performance, but we need to balance between the which technology and which technology to come up in the university to come up to have the infrastructure total solution. Okay, maybe my friend want to add something, Dr. Bat. Okay, so thank you very much.
Thank you very much, Bakar. I've never heard of GPON before, so you've introduced me to something new today, GPON. Right, question please, ladies and gentlemen. Bakar has come a long way to be with us, please.
Thank you. Yes, GPON is new for me too. What about the integration of the GPON and the traditional network? Because I think the implementation will be in different area and they can be go side by side.
So maybe I give to my colleague to answer this question.
Thank you very much. Actually, GPON and Ethernet is two different technologies. So usually what we've been used is Ethernet. So Ethernet at the offices, data centers. But GPON technology usually used at the home, like fiber to the house. Like the broadcasting system, they use FTTH. But the paper that we presented here is to help engineer to design which technology to be used. For example, within the offices, within the data center, we can still use Ethernet because it performs superior and quite consistent in terms of the performance. But if the university has student accommodations, so it is advisable to use the GPON technology. So it is more cost effective and suitable with the traffic types, the way users use internet. So that's where we need to balance and to properly design. Yes, this can be integrated. Actually, GPON and Ethernet can be integrated together. It's just a matter of how many splitters to be used for GPON and where it can be used effectively. So it can be integrated together. Thank you.
So you can see one case study in US, the university in US, they use total GPON. They don't have the internet switch.
No.
So, and they claim they are success. You can see that the cost is quite low. Okay. Okay, thank you.
Thank you very much, Bakar. Thank you, ladies and gentlemen. May we give a round of applause again? There we go. Excellent. All right. Okay, we know Alicia has been waiting in anticipation online. Alicia, you are with us?
Yes, I'm with
Paper
you.
65. We're going to be looking at deep analysis of image classification and to do with a word which I learned recently, histopathological images. Please, Alicia, it's over to you. Share your screen, please.
Sure. Good afternoon, everyone. I'm Alicia Khan, and thank you for giving me this opportunity to present our work on deep analysis of image classification architectures for detecting cancer cells from histopathological images. My co-researchers are Tawhid Bhuya and MD Maruf Hassan. I would like to share about our background and motivation, then literature review, our problem statement, our research objectives, contribution, and our methodology, result, conclusion, and our future work. First of all, I'd like to talk about our background and motivation. As the cancer disease is spreading widely, the detection of cancer cells have become a challenge of the oncologist. Besides, manual detection of cancer cells from the histopathological images is very tiring, and there are chances of the human error. Therefore, many convolutional neural network-based image classification architectures have been invented to detect cancer cells. However, there is a less study about the performance comparison between the architectures. Therefore, there is a need of comprehensive study between the architectures, image classification architectures to detect cancer cells. There are many studies and researches that have been conducted on analyzing architectures for detecting cancer cells. One of the study is in India presented a rare yet consequential skin cancer cell where they have used VGG16 model to improve the treatment of skin lesions. However, there is a research gap in this study, which is they have used VGG16 model, but there is no comprehensive study and the performance if they use other models rather than VGG16. Besides, they have used only one type of cancer, this is skin cancer. And the study in Turkey explained the detection of breast cancer cell with VGG16 and ResNet50. Their research gap is they have only used one type of cancer, which is breast cancer, and they have used VGG16 and ResNet50. There is also lackings of comprehensive study and comparison between the other architectures as well. There is a recent study focuses on detecting lung cancer cell with CT scan images, and they have found that VGG16 is the highest accuracy. They have also shown the comparison and some analysis between the VGG16 ResNet50 Inception version 3 and MobileNet version 3 architectures. However, they have only used only lung cancer cell and CT scan images. As we know that for detecting cancer cells, histopathological images gives us the better result than CT scan images to detect the cancer perfectly. Therefore, the problem statement is there are many convolutional neural network-based architectures which has been developed. However, most of the studies focus on only one type of cancer, mainly lung cancer, skin cancer, or breast cancer for detection with the invented models. However, there is a limited comparison and comprehensive study among the deep learning image classification architectures for detecting multiple cancer cells. So our research objective is to present a comprehensive study and PV comparison among the image classification architecture to detect cancer cells from histopathological cell images. And our another objective is to use not only one type of cancer cell, but multiple cancer cells, which is lung cancer and colon cancer histopathological image datasets. So our contribution in this research is that firstly, we have studied a total of 5 image classification architectures, which is VGG16, MobileNet version 2, Inception version 3, Exception, and DenseNet 1-to-1, and implemented them in not only one type of cancer, but 2 types of cancer, which is lung cancer and colon cancer histopathological image datasets. And to find the accuracy of each model for each dataset individually to present the performance of the models. After that, we have compared the results with each other to find which model yields the best result for each dataset and presented a comprehensive result and study to detect cancers. Here is our methodology. First of all, we have collected the lung cancer dataset, histopathological image dataset, as well as colon cancer histopathological image dataset. We have pre-processed it, train and test split with 80%, 20% data. After that, we have compiled and feed the models in both datasets individually. If we have found any overfitting problem during our implementation, then we have tune it to solve the problem, overfitting problem. And if we didn't found any problem, then we just go for validation and testing. After that, we have found the binary accuracy and performance matrices for both lung and colon cancer detection and present and calculate the average accuracy of the models. Then we have compared the accuracy with each other and analyze which model best fitted for cancer detection. In our case, we have found VGG16 have given us the best accuracy. This is our data set for lung cancer and colon cancer. We have found total of 10,000 lung cancer histopathological image data set and colon cancer, a total of 10,000 28 data set for colon cancer data set, and both lung cancer and colon cancer are divided into 2 classes, which is normal cells and adenocarcinoma cells. Therefore, we have found the binary accuracy. For data pre-processing, we have resized the data with 224 into 3 RGB images, and we have done the data augmentation with random horizontal and vertical flipping, as well as random rotation, and we have done the normalization on the images. So this is our finding result. We have shown the comparison of the performance matrices of the architectures. For the VGG16, to detect the lung cancer cells, the accuracy is 98.9%. For detecting the colon cancer, it is 99.35%. And for MobileNet, to detect the lung cancer accuracy is 97.8%, and for colon cancer it's 97.8% as well. For DenseNet, it is 98.3% to detect lung cancer, and the accuracy is 82.95% for the colon cancer dataset. And for Inception version 3, the accuracy for detect lung cancer is 99.65%, and the accuracy for colon cancer dataset is 97.95%, and for the exception model, it is 99.65% accuracy for lung cancer and 96.1% accuracy for the colon cancer detection. After analyzing the average accuracy between these 5 models, we can see that VGG16 model is giving the highest accuracy with 99.1%, where VGG16 is detecting the cancer cells correctly. This is the confusion matrix that we have created for the detection of lung cancer and the colon cancer from histopathological images. From this confusion matrix, we can see that total of 1,000 data out of 2,000 test data is giving us correctly showing us detecting the infected cells as a infected cells, whereas for colon cancer histopathological images, it is 993. During our implementation, we have found some overfitting problem with the hyperparameter epoch number 30 while training the VGG16 and DensNet 1 to 1. Therefore, we have fine-tuned this epoch number from 30 to 20. This table is showing that when we have found the overfitting problem, what is the accuracy and the loss for VGG16 and DensNet 1 to 1. To sum it up, there is a very little study where multiple architectures have been implemented and analyzed to detect cancer from histopathological images of the cells. Therefore, we have implemented and analyzed 5 deep neural network architectures before reaching to the conclusion that VGG16 yields the best accuracy. We have also presented a vivid comprehensive study of the performances of all the 5 architectures. This comprehensive study is crucial for choosing the architecture to detect any type of cancer cells. Besides, this study is also crucial for the development of new architecture for detecting cancer cells. For our future work, we would like to expand our work by using other types of cancer histopathological cell datasets, for example, breast cancer, blood cancer, and so on, to present a more vivid comparison between the architectures. We have also used binary classes, normal cells, and adenocarcinoma. So we are planning to expand the classes number and use the multi-class and besides, we will try to develop a more sophisticated model which will give more accuracy than the VGG16 model to detect cancer cells at an early age. This is our references. Thank you. If you have any question, please feel free to ask me.
Deep analysis. We really appreciate it. Thank you. And we're asking the audience here for a round of applause, ladies and gentlemen. May we just say thank you to the presenter. All right, there we go. Excellent. Now we have a number of questions. We're going to go with Erica first. Yes. First with Erica. Erica first. Thank you, Erica. You use this one, Erica. Use this one.
Hello, my name is Herika. Thank you for the presentation. How was the data set collected and selected in this research? Do you use real data set from hospital or just from open source data set? Thank you.
Thank you for your question. We have used Kaggle to collect our data.
Which is an open source, is that
open
correct?
Source, yes.
That's open source. Open source, yeah. No, sorry, I must first come here now. I'm coming back there. Your question. Yeah, you can.
Madam, you have used other network other than the VGG16? Because ResNet 50 or ResNet 101 are better network for this kind of the work in current scenario. So have you compared your study, your research on ResNet 50 or ResNet 101?
Thank you for your questions. We have used 5 architectures, but we are planning to expand the work. So in the future work, we'll try to add the ResNet 50 so that our work can be expanded.
Okay, because ResNet 50 and ResNet 101, they are having the facility of residual blocks.
Yes.
And which basically ultimately outperforms in comparison to the VGG16. and then you will get the better result.
Yes, of course, you are correct. Another study has been conducted, which I have also presented. They have also compared with VG16 and ResNet. They have found that VGG16 is performing best among them. So I prefer to use VGG16.
Fine. Okay.
One more question, Alicia. Please don't go. Don't go. Yes, one more
Sure.
question.
Thank you. That's very good research. I want to know, do you also research your member? I mean, with the domain expert of doctor or maybe hospital?
No, I haven't researched with doctors and hospitals yet, but if we expand this work, so I think we will be needed to talk with the hospitals and
Yes, because the accuracy is very high, 99% is almost perfect, So sometimes in our case, we also create a model, but once we drop it to the hospital or to the doctor or domain expert, sometimes it's not, not high like that, because in the real system, maybe it's a bit different with our model. And that's, I think, the big problem of IT people and other, maybe with the users. Because sometimes we think that our model is very perfect, but once we send it to the real system, sometimes they do not match with our model. So yeah, I suggest you to find a doctor or hospital to test your model. Thank you.
Yes, this is some of the limitations that we will need to work on.
All right. Thank you very much, Alicia, for your presentation. It was lovely to see you. You are excused.
Thank you.
Ladies and gentlemen, sorry, I know we have one more presentation, but we have to break for lunch because it's already past 1 o'clock. Let me just quickly hear, Abdullah, are you online?
Yes.
Paper 66?
Yes, I'm here.
I'm sorry, Abdullah, but we're going to first have to break for lunch. We have been deserted here by a lot of our audience. We're going to start at 2 o'clock again, Abdullah. So please excuse us, but we have to go for lunch first.
Okay, no problem.
Okay, so exactly in 55 minutes' time, we'll be back online for your presentation and then for the rest of the afternoon's presentation. Thank you very much.
Pradesh. Our research is being presented at 9th International Conference on Recent Trends in Computer Science and Engineering. Now, here is my presentation outline. First, introduction. To begin, let's take a look at the scope of our study. Nanotechnology involves manipulating the materials at the nanoscale, which spans from 1 to 100 nanometers. At this scale, we can design incredibly efficient materials and systems. However, nanotechnology faces significant challenge, especially with the material design, defect detection, and process optimization. Artificial intelligence offers solution to these problems by integrating AI methodologies such as machine learning, deep learning, reinforcement learning, neural language processing. We can outcome this challenge and the pitch of the innovation in the nanotechnology. Despite this advantage, there is a gap in understanding how AI can be systematically customized for the different nanotechnology application. That's where our research fits in. Now, problem statement. Now let's look at the key problems we aim to address. We need interdisciplinary collaboration to maximize the potential of AI in nanotechnology. The challenges include AI integration gap. Research is lacking on how AI can be adapted to the specific nanotech problems and limitation of traditional method. Existing model struggle with the complex nanoscale interaction which traditional computational method fail to address. And nanotechnology challenges the issues such as complex material design and scalability are the prominent the barriers that AI can potentially resolve. So, what are the key objectives of our research? Our main goals are to review AI methodologies. We explore the application of machine learning, deep learning, reinforcement learning, and neural language processing in nanotechnology. Second, identify AI impact. We examine how AI can drive advancement in material discovery and optimization in nanotech. Then thirdly, evaluate strength and limitation. We assess the capabilities and constraints of this AI method in real-world nanotechnology application. And fourth, provide the insight for the future research. We suggest future direction to overcome the challenges and improve AI-based solution in nanotechnology. Literature review. Here's a brief overview of the research we reviewed. AI has been making uh, substantial stride in the nanotechnology. In machine learning, extensively used for the material property prediction and optimization. For example, supervised learning model have been shown to improve the material stability prediction. And then deep learning. CNN have successfully been used for detection in nanostructure and its large database and high computational power. Reinforcement learning applied in nanorobotics and process optimization, such as drug delivery. And the neural language processing technique are helping to extract the useful insight from the vast scientific literature. Our methodology develops into these four key AI techniques. First, machine learning. It helps predict, classify, and optimize nanomaterials. Then, second, deep learning focuses on data analysis, defect detection, and modeling for nanoscale materials. Then reinforcement learning optimize process and controls nanorobots for specific tasks. Then neural language processing uh, extract trends and discovers novel materials from scientific literature. We have used comprehensive literature review and real-world dataset to evaluate this AI method. First, machine learning. Let's take a closer look at machine learning and its application in nanotech. First, supervised learning. It predicts the properties of nanomaterials based on the labeled datasets like nanoparticle size or conductivity. Second, unsupervised learning finds pattern in unlabeled data, helping us discover new materials. Then thirdly, semi-supervised learning. It combines the two, the supervised and unsupervised, labeled and unlabeled data to improve the accuracy in classifying the nanomaterials, especially rare ones. Then deep learning. Next, we explored deep learning technique in nanotechnology. First, CNN. It used for high-resolution imaging to detect the defect in nanomaterials. Then RN, a recurrent neural network. It simulates the time-independent phenomena like the diffusion of nanoparticles. Autoencoders. It reduces dimensionality of complex datasets, it making it easier to analyze nanoscale data. Reinforcement learning helps us to optimize and control nanorobotics. First, Q-learning. It optimizes the movements of nanoscale robots for tasks like drug delivery. Second, deep Q-learning. It trains nanobots to autonomously carry out tasks like the molecular assembly. And third, the policy gradient method optimizes self-assembly process for the nanostructure, improving the reliability and nanoscale the fabrication. Then neural language processing. Finally, let's discuss how NLP can help with the nanotechnology research. First, text meaning extracts the key terms from the scientific literature, helping us identify emerging materials. And secondly, named entity recognition links material composition to their application. And topic moduling, it identifies the pattern in research topics, helping prioritize and future nanotechnology research. Let's now look at the performance of AI methodologies in nanotechnology. AI methodologies, particularly machine learning, deep learning, reinforcement learning, and neural language processing, each play a significant role in advancing nanotechnology. However, they have also their limitation. And first, machine learning strength dependent on high quality dataset and may face the interpretability issues. And deep learning, while it effective for the defect detection, it requires subsequential the computational resource. And reinforcement learning, although it helps with the process optimization, it faces scalability challenges. And last, neural language processing, it excellent for knowledge extraction, but domain specific adaptation remain challenging. Now, challenge and future direction. While AI has great potential, several challenges still need to be addressed. First, data issues. We face a scarcity of high quality, domain specific dataset. Then, model complexity. Uh, Advanced models require large computational resources and often lack the interpretability. And experimental integration also one of the challenge. AI prediction often need to the experimental validation, which can be difficult to align with the real world nanotechnology application. Future direction, uh, it domain specific data sets. We need the collaborative platform for the collecting the more targeted data. And another is explainable AI. We need to build trust in AI models by making them the more the transparent. And last, the hybrid model, integrating AI with the physics-based simulation with the physics-based simulation will improve the precision of the prediction. Here is the wharf up. Here are the key takeaways from our research. AI transformative rule AI is revolutionizing nanotechnology, addressing complex issue in material design, defect detection, and process optimization. And key methodologies, machine learning, deep learning, reinforcement learning, and neural language processing, each contribute is unique ways to the advancing nanotechnology. And challenging remain, there are still challenges to overcome, including data dependency, computational complexity, and the scalability. And future prospect, AI will continue to the drive the breakthroughs, but interdisciplinary collaboration is the crucial to the unlocking its the full potential. Here is the reference, and thank you everyone, and gratitude for your attention.
Thank you so much for your nice presentation. So I have a one question. What is the feature side in your nanotechnology where you are planning to integrate AI?
Can you repeat the question again?
Yes, feature side of your nanotechnology where you are planning to integrate AI for integration purpose.
Nanotechnology involves the manipulating materials that it's nanoscale. However, nanotechnology faces significant challenge, especially with the material design, defect detection, and the process optimization. Uh, Here, the artificial intelligence offered a solution to these problems by integrating AI methodologies. I described already the machine learning, deep learning, reinforcement learning, and neural language processing. That we can overcome this challenging and accurate the pitch of the innovation in nanotechnology. And despite this advancement, there is gap in understanding how AI can systematically customized for different nanotechnology application, and that's where our research fits it.
Okay, thank you so much. So next paper ID 67, Mr. Rajesh Pandey. So Rajesh, are you available? Paper ID.
Hi sir, can you guys hear me?
Yes, yes. You may share your screen.
Yeah.
Yeah.
Just looking for my slide. Can you guys see my screen?
No.
Not
Yes.
yet?
Yes, yes, we got it.
Okay. Hi. I'm Rajesh. I'm a senior IEEE member. I'm based out of Seattle, and two of my co-authors, Amit and Zubin, I think they're on the call. Today, I want to present my paper around bust-aware weighted fair queuing for serverless inference. The research was sorry, I check you guys. Yeah, so serverless platform is basically where you don't lease a server or pay upfront, where you can run multiple tenants, and it's kind of like a leasing model where you lease a box to multiple tenants. So you kind of share the cost across, and then it makes your cost at a scale much more cheaper to run your workloads on. There are different kind of workloads that you can run on like serverless platforms. One is around like interactive workloads, and then one is like batch workloads. And this paper specifically targets what the behavior around when like you share a common backend which is being shared across two types of tenants. One is like interactive tenant and one a busy tenant. And what are the different techniques that previous papers have tried implementing, and like where they have lagged. We tried to find an approach where like an FCFS model, like where a single tenanted, like a single backend system being shared between two types of tenants causes a problem in terms of like causing the noisy neighbors, where one of the tenants who has a lot of work to be done can actually consume a lot of like resources in the backend. And when it does that, like it sends a huge amount of workload. The customers, those who are well-behaved customers, they might not be able to use the resources in the backend, and they see a disproportionate amount of latency for their applications that they are serving. So this is typically called as like a noisy neighbor, where like one customer has ended up consuming a lot of more resources than the others that is available in the case of like a shared environment. So this was a real the motivation that I had from like we had for this paper was around like where we were sharing, we were running like a simple workload. It was running happily and like everything was working fine, and suddenly we ran a backfill job. That backfill job was run in like a batch format, which ended up consuming a lot of resources in the backend. And that led to like you can think of an example where like you are interacting with a website, you make a call, you get a response, but suddenly in the back end you are using an LLM model, and I ran a bad job which ended up consuming all the resources or all the API limits that are available. And so the well-behaved customers started seeing that ATX increase. So that was the motivation, and then I started doing some research. We started doing some research around like what are the things or what are the ways through which we could implement. We went through like some of the literature that already exists in terms of like FCFS and like DFQs. So what could we do so that we can further improve it? Based on the problem that we had at hand, we defined an algorithm which is around like using the token bucket to control the rate at which these different kind of tenants can be ingested into our system. So you can think of it a, uh, a tenant who is like an interactive tenant, for example, will come into the system. It will ask for whether I have the result token for myself so that I can go ahead and fire an LLM inquiry in the backend. Similarly, for the batch workload, they will also come. What we did is like we used a technique where we divided the number of tokens in the proportions, where like an interactive is getting higher chances of getting success. So the tokens which were dispensed to the interactive tenants were higher in proportion to the one to the batch ones. And we implemented a min heap priority queue, where you whenever there is a tenant comes, first we check whether that tenant has some sort of tokens with it, and whether those tokens are still active. It can consume one token, go back and then execute its query, and comes back and decrements the counter. So that like these are two types of token buckets that we implemented, where like anyone who comes first grabs and sees that whether there is an like available token for it, then goes and decrements that token when it's done. Similarly for batch, same batch job will come and it will grab a token and then decrement the token, but the ratio is different. If there is no token available, then they will get into a queue, and then they'll say that like how many tokens are active in consumption and how many they have consumed so far, to like us decide on like who should get the next share of the tokens when it gets refreshed. So this is like a high level overview of the workflow that is like a VWFQ scheduler that we implemented. So an interactive tenant comes in, it requests an entry, checks for the token balance, whether token is sufficient. If not, then it goes into the min heap queue that I was just talking about. If it has sufficient token, then it goes into the dispatch logic, and behind the scene it says that okay, this is my state of the tenant. So it token earns, token is spent, and that is what you use to compute whether it has sufficient token and if it should go into like min heap queue or not. And if it has that, then we execute the happy path and execute the function. It's a simulated environment where we simulated all these things. And we ran this simulation for thousands of times for like a Lambda style workload. Lambda is an AWS offering. where you can run, you can ask for a compute on demand. We ran the workload profiles were around like where interactive queries were taking 50 to 120 milliseconds, and batch jobs were taking 8 to 15 milliseconds. So you can think of like if a job is going to take 8 to 15 milliseconds, then it will consume that resources in the backend, and there will nothing be available to the interactive workloads, and that's where like the whole problem came into. And we measured across latency, throughput, and fairness, and the efficiency of our setup. We got good results after implementing these like by token buckets, where ingestion and the like decrement of the tokens happens. We saw an increase of 4x in P99 latency, where like an interactive client didn't get impacted, where in the earlier cases they were like seeing a latency of like 8.5 seconds that they have to wait when there is a batch job running. Now it got reduced to 2.1. And the throughput is still like, because now we introduced this scheduler in between, so throughput has a slight impact onto it, like so it dropped from like 100% to like 94%, which is much better than like what we were getting earlier, because in terms of seconds it was going back to like a 10% of the throughput that we were having. And the scheduling overhead, that scheduler that I talked about, introduced like a 34 microseconds, so negligible in terms of like what you the benefit that you were seeing. And these are the stability and fairness metrics, because the motivation was like our interactive tenants should get the fair chance of serving the traffic. So based on this, like you can see like at certain point uh, the tenants and the workloads which were being distributed were actually fairly working with each other. And fairness was maintained when even there was like bust was happening, because you were consuming the tokens which were available, and the ratio we divided for the setup, we use 15:1, the ratio for interactive workload versus the batch. So it performed pretty well. And the implementation, the whole algorithm, it's just like I have included that into the paper itself. It took us less than 150 lines of Go code, and the ratio was like 15:1 for batch to interactive. And like we added some like metrics around like how many tokens are available, and like how many you can actually probe. You can launch your CLI, and you can actually actively probe these token buckets on like what is it's like a memory map state that you could see. Finally the conclusion is like this was very simple to implement. It was just trick around like how do you set these token buckets in conjunction with like your workload profile, so that you can actually set these set of like profiles. Currently the this setup, which is like very static in nature in terms of the rate at which we refill the tokens, were static in nature, but like it could easily be extended into terms of like you can look into the CPU profile of your shared tenant, like where the workload is going to run, and like CPU memory and like other set of like file IOs and all, and see like whether everything is working or you can further improve this algorithm. That was pretty much it. Happy to take questions. Thank you.
Thank you so much for your nice presentation. So I have one question. What is P99?
Okay. So like in terms of like latency profiles, like what P99 is, it's like a median. You can say that like out of like 100 requests, how many of the requests, like the 99 of the requests took the execution time less than that. So that is how like how you plot the latency distribution. And the P99 was that like 99% of the requests, or the metric that I was checking at, was actually below than like 10 to like 120 millisecond, that number that I was observing.
Okay, thank you. So any question from audience? Okay, thank you, Rajesh. We'll see you again.
Yeah. Thank you. Thank you, sir.
So next paper ID 45, Paulina, are you available? Okay, anyone are ready to present online, or we will switch to offline? So in a Zoom, anyone ready to present now? In Zoom, anyone who is waiting for presentation, just raise your voice. Okay, then paper ID 63. Where is Siti? Paper ID 30. 30.
Anggi will present something. So,
No, but we must give the new chairperson. Umi must be the new chairperson now.
oh no,
Jason says Umi now. Umi and Shukla. That must be the same.
Paper ID 30 CT Smart Alert System for drowsy driver using.
your mic.
Yes. Paper ID 30.
Hello.
Yes.
Hello. I am Dalila.
Yeah, what is your paper ID?
30.
Yeah, please share your screen and start presentation.
Louder.
Oh, chairperson this morning.
Yeah.
I'll let you up after this one.
I will wait. Yeah. Okay. So after all.
But this is the first. Okay. Who are we waiting for? Online. Oh, online. Okay.
Yeah, Siti, you may start your presentation. Yes, they say I want to inquire.
Not exactly.
Sit.
Alert system for drowsy. Okay. Can you see my slide?
Yes.
Okay, can I start now?
Yes.
Okay, thank you. Okay, this is my project smart alert system for drowsy driver using cascade classifier and deep facial landmark. I am Dalila from University Sultan Zainal Abidin, Terengganu, Malaysia. Okay, this is my outline for today presentation. I will talk about introductions, literature review, system framework, result discussions, and conclusion, and I will end with future work. Okay, for the introduction, the drowsy driving has been identified as a leading cause of traffic accidents, significantly impairing driver attention and reaction times because of we are so sleepy while during our driving. It cause us it will compromise our decision making, situational awareness, and also vehicle control. Okay, this study introduced a drowsiness detection system based on facial behavior analysis. The system employs HAR cascade classifier delete facial landmark detection and the eye aspect ratio to monitor and assess driver alertness. When signs of drowsiness are detected, the system triggers an immediate alert to the driver, aiming to enhance the road safety and prevent fatigue-related accidents. Techniques are generally categorized into behavioral, and the third one is vehicle-based approach. This vehicle-based approach means measure the measure track factors such as
Sorry, Miss, your connection is not good enough, maybe.
deviations,
Dia mungkin nggak bisa
steering wheel movement and accelerator pedal pressure.
Stable connection.
Any changes to
Your connection is not good, Miss. Yeah, unstable. So we cannot hear your voice clearly here. Huh? Oh. Yes, yes. Yes. Is that your connection there can be fixed or not? I think she is freezing. So maybe you can present later, Dila, ya, after your connection is good. Bisa di stop ya, Camat. Dia nge-freeze dia. Tapi di Zoom ada siapa? So the next presenter because she is freezing.
Yes, yes. So
the next is Anggi.
Oh my God. Yay! We've been waiting all morning just for you.
Okay. Many haters there.
Ask you a million questions.
Yeah, you can present later. No? Ya lanjut.
Ya, seperti ini.
So your connection's good now?
Yeah.
Dila? Oh, okay.
Yeah, yeah.
Okay.
Can I continue?
Yes.
Okay, for the literature review, drowsiness detection technique are generally categorized into three approaches. The first one is psychological approach, the second one is behavior approach, and the third one is vehicle-based approach. The vehicle-based approach measure track factors such as lane deviation, steering wheel movement, and accelerator pedal pressure. So any changes to this approach, any changes to this metrics indicate that the driver is drowsy. The second approach behavior method involves using camera to capture driving behavior, such as yawning, eye closure, blinking, and also head position. So with alert trigger when the sign of sleepiness are detected. The third approach is psychological measure, as a mean that the relation between psychological signals such as electrocardiograms and also myograms, EMG, and driver fatigue. So among these behavior-based method favor for real-time application due to their non-intrusive and ease of implementations. So several studies had employed artificial intelligence, CNN, and also IoT and OpenCV framework to enhance detection accuracy and system responsiveness. So despite advancement, challenges persist in handling dynamic lighting, facial occlusions, and ensuring consistent real-time performance across conditions. So this study proposed efficient and adaptive solution using Haar cascade, delete facial landmark, and also eye aspect ratio optimized for drowsiness detection. So this is the framework. In this framework, the webcam will capture the video of the driver, and then in the image acquisition, we take the frame by frame and analyze that frame using Haar cascade classifier algorithms. So we using Haar cascade classifier, we capture the facial the face of the drivers, and then we use the result from face detection. We use facial landmark detection to identify the eye, the nose, and also the mouth of the facial drivers. And then with that result, we use eye localization and calculate the eye region of interest. So if based on this result, we compute eye aspect ratio, and then if the value is under the threshold, so means that below the threshold means that the driver is drowsy, and the alert will alarm the drivers. So this is the result of our implementation. We only test on 6 drivers with number of frames 13, and then you under the several conditions, light, dark, and wear spectacle, and also turn our head turn 60 to 90 degrees, and also right position and left positions. So for the light on and dark and also wear spectacle, we achieve 100% detections, 100% of drowsiness detections, while for right and position we got 96 detections, and then for the 60 until 90 degrees of turns, we only achieve 78%. So this is the graph that shows the awake conditions and also drowsy conditions. The first graph shows that the ear value is in the awake conditions. The ear remains between 0.25 until 0.31. Means that the driver is awake in awake conditions. And then for the right graph, this is the for drowsy driver, and then EAR frequently drops below 0.13, means that it's a drowsy sign. Okay, for the conclusions, facial behavior can help to detect accurate drowsiness detections because of this facial behavior we don't need special equipment, just a webcam, and we analyze the video from the webcam. And then this is cost effective and non-intrusive compared to psychological method. And it's achieved 100% accuracy in ideal conditions, and with this it helps to enhance the road safety by alert the drivers. So for the future work that we aim to do is to do the real world testing in actual driving environments. We also want to add the evaluation metric, precision, recall, and advanced score. And then we want to improve the performance under real situations, means that in stream lighting and also occlusions. And then we want to expand the data set, since the testing we are doing only on 6 persons. So we want to extend the data set and subject diversity for reliability. That's all from me. Thank you.
Thank you. Give applause to it's yours.
Yeah, thank you, Siti. After lunch, I'm also feeling drowsiness. So how your research is going to help me? And even after, when I go to classroom for teaching, my students after lunch timing, they start feeling drowsiness. Yes. So I can install your research in my room, and if a student will feel drowsy, it will send me alarm. Your restaurant number, this is sleepy. Okay, thank you. It's a very good research.
Okay, maybe I want to ask, sir.
Yes, please.
Yes, I want to ask you. You wrote that the accuracy 100%. I don't know. Maybe for me as an IT woman, 100% is too good to be true. Even sometimes I only confident if the accuracy only 80% or 88. It's normal. But 100%. Do you confident with 100% accuracy or
we get 100% accuracy because we only test on 6 drivers with control environment. Because I think if we do it in real environment, we can get that.
Oh yes, because the 6 people aware that they controlled by something by something. Yeah. Okay. Thank you.
Okay, thank you, Siti. We'll see your presentation again in our next conference. And now the next presenter is NG Fabian, our youngest speaker.
Anggi, not Anggi. No question. Anggi, not Anggi.
No question, please.
Okay, thank you for opportunity to me, sir. Good afternoon and go home. Come on. Today I want to share my research paper. This is just little research because this is what's name SLR, right? SLR, Systematic Literature Review. So this is small research. We want to know cybersecurity in heavy equipment. I think heavy equipment is very manual, but right now we have the offline. It's okay. And then also I'm not a researcher, sir. I am a practitioner from industry. No question, okay, no question. You have the 100 question, no question. Bukan. Judulnya Cyber Security in Heavy Equipment.
I know.
999.
999.
I forget. Oh, it's already. And the author already in here, Prof. Biswajet and Bu Debbie from Trisakti University. All right. The yellow power. Okay, the title is Cyber Security Technology on Heavy Equipment, a Systematic Literature Review. Because right now, what is name? Heavy equipment is can be autonomous, can be working by itself with the program. So we need a scare. I scare the unit is moved by itself and destruction the building is just not following the true work, you know, like this. Okay, next. Next. This is autonomous open pit of mining, coal mining, yeah, coal mining. Many heavy equipment, dump truck, excavator. This is hole, making hole for blasting, yeah, and then this is a conveyor, yeah, conveyor and stockpile, and every unit in here is autonomous. The unit is working by itself because the first we input the program to make the mining is running well like this, and I make a hole, a big hole. And the implemented of the autonomous is in China and Australia is already implemented. Indonesia is already trial in central of Borneo, Oh my God, okay.
Shut up now, he's busy now. Wait now, leave him.
Yeah. I'm so sorry. Yeah, okay. Also India.
Stop interrupting him now.
For slide, you have many questions. All right, next. So, okay, and then the autonomous driving mining vehicles is what's name? The driver is from cloud, IoT, and everything. The Wi-Fi, RFID, everything, any in the unit. And then what the impact hacking heavy equipment? This is involvement autonomous is the first operational disruption, physical damage, safety hazard, data, and then financial losses. This is the impact if anyone hacking the heavy equipment. Right? Okay, and then I'm in this research is to identify trend, methods, and research finding in the related cybersecurity in heavy equipment. The research question, I have the two research question. The first is what are the latest research method and objective about the cybersecurity in heavy equipment, and then what challenge and solution in the literature from 2021 until 2025. And then this is the step of research. Method is a systematic literature review. Database I get from Scopus. Keyword, the process keyword is cybersecurity. And then article screening, we just screening abstract and then key finding. Yeah. And then analysis objective and method. All right. Okay. This is protocol of systematic literature review. The first, purpose, database, we take it from Scopus, and then keyword, we using the cybersecurity. technology on heavy equipment, publication range, and then inclusion criteria, it should be English, and then focus to keyword, and exclusion criteria is just text, yeah, screening of text, screening procedure, we filtering by year, by scopus, and then by keyword, and then analyze. We just analyze descriptive analyzing. Okay. Okay. Hey. Okay, descriptive analysis of objective. From the 75 papers relevant, I have 11 paper very relevant maybe. And then I try to make the summarize about the contribution and finding and objective in here. The first is about the identify critical gap in cybersecurity maintenance. So any one paper write about the critical gap about cybersecurity in maintenance, and then the second about the digital twin in process testing management, and then cyber physical system with IoT and AR, augmented reality. Yeah, this is about the machinery safety construction and testing, and then any heavy equipment cybersecurity, and then IoT IC framework, CPS telematic full automation, and then GFCM cyber threat automation, and then AI model. And then the method, we see the method, many method already right in the existing paper, like mixed method, TAM method, framework development, case study, SLR, we found prototype development, bibliometric, fuzzy, and conceptual model. Okay, in the last, the conclusion, because this is the little research, yes, sir. Please don't ask, sir. Okay. This is the cybersecurity gap. This is there is a critical lack of cybersecurity in maintenance after machine warranty, and then the high potential emerging technology. This is such as DT, CPS, IoT, AI. Yeah. And then future research, this is emphasized should be placed on life cycle security strategy and collaboration between academia, OEM, and industry, yeah, for real world application impact. Maybe that's all for me. Thank you, sir. Give me applause, please. Okay, thank you. Don't ask, okay, okay. Okay, sir. What do you want, sir? Oh, okay. You know, Mr. Biswajit. Very, you know, sir. My first conference in here, 2023. And this is the first day I'm to be student a PhD. And right now, 1st July, the last to be student study because this is the last semester. And then the first week in July, I will pass a final presentation of my PhD. So it's already long process with Mr. Biswajat. So thank you. This is my lecture.
Yes. I also want to know. Don't worry. Sir Biswajat will bring you to India. Maybe next year. It's interesting that we also have IoT and IoT project in YARSI. So I think Bu Kusri he can be one of the client to develop these things.
Yeah,
in
of course.
In the real, because we also need collaborate with industry.
Yeah, of course.
Yes, because in our study program, we have a subject that what we call project-based. So yes.
So you may write as a professor of
Yes, the student have to have real have to fit. Yeah, make something real problem from the client.
Because his wife is staying in Jakarta and he's going to Surabaya program on PhD. Let's give him a getting position here. So
stop finding jobs for everybody. Great job to find a job.
Better than you.
Yes, Pak Anggi, I think your research is very interesting, and it's not a little, not little research, but it's a very impactful research. Yes.
Yeah, thank you. Because in PhD, this is just introduction, for to see the gap of the research. Okay. Okay, thank you so much for your time, sir.
Most awaited person. So now we are going to invite the most awaited person, the global researcher and the professor of the year, Dr. Arthur Jameson.
I have a question. Yes. Ask your question. Predictive question. You were using AI to predict.
No material.
RTC, where's the ones? You know the ones you copied for me. SWOT. That one. Yeah. Terima kasih. May I start, Chairperson? Chairperson, may I start? Terima kasih. Good afternoon, ladies and gentlemen. I am here to discuss with you research findings which we did a few years ago on PhD thesis. We did this research using Python. So we had a software developer. We explained the process to you just now. We had a software developer who downloaded and extracted the data for us. We just put it into Excel to make the graphs. We have another researcher now who's going to try and attempt doing the same with ChatGPT. In other words, with AI, also to extract, analyze and see if they can come up with the same results. Of course, there's a lot of prompts involved, specific prompts that they will need to come up with. And the aim of that research is to provide a framework to other researchers if they want to do something similar, a framework from which they can work. But again, this is based on Python from a software developer. All right, let's move to how long does it take me to get here? So there is Bloemfontein in the middle of South Africa. All these dots, don't worry about them. So it's about 16 hours, and then it's about 4 hours waiting in Singapore. No, 4 hours in Johannesburg, 2 hours in Singapore, 2 hours in Bloemfontein. So 2 plus 2 plus 4 gives you 8, 8 plus 16. It's about 24 hours. From when I leave my home until when I walk into the accommodation here. So it's quite tiring. And of course, you fly over Mauritius, but you don't see anything. Right, that's where my office is, just there on top. I sit over there. This is the Faculty of Engineering, Built Environment and IT, Information Technology. We have just that one hill there at the back. Sorry, there. We have that hill. We call it Naval Hill. Do you know the word naval? Naval? Anybody? Naval? Naval, eh? Naval. Yeah. Naval, eh? Yeah, naval. We call it Naval Hill. Don't know why they call it Naval Hill. It doesn't look like a naval, but anyway, it's called Naval Hill. And then this just shows where I come. So I come down from my home, I come down this street, and then I turn in there, and then I go park. I park just next to my office, more or less. So I'm very fortunate. Information is not knowledge. Is that true? Yes. Because remember, information can be raw data. And with raw data, you can't do anything. It's like raw chicken. You can't eat raw chicken, isn't it so? It needs to be processed, it needs to be cooked. So too with information. Information needs to be processed in some other way so that we can make an informed decision. So it must be converted into knowledge. So, information can be drawn from a number of sources. The internet, it's a major source of information. But that does not necessarily mean we have knowledge yet. So we have to transform. And so here are 5 reasons why I would use not the internet, not newspapers, not journals, but postgraduate thesis. In other words, PhD or master thesis. Why would I want to gather information from those theses? So yes, 5 thoughts mentioned here. The most important one here, and number 4, describing supervisors and practices that are embedded in the discipline. So from discipline to discipline and from supervisor to supervisor, there can be different approaches to how the thesis should be structured and what should be included. But we can also have a look at this last one. We can see what a university is doing. If we look at their theses, which is contained on an online repository or in a public space. In this study that we did, we looked at the differences now between the disciplines because that's a reason for looking at the information. But we also went to go and look at what was the focus of this study. Because remember, we say we can look into the university, we can see what type of research they are doing. So we wanted to know that. But we also wanted to know what citation analysis had been used, or what type of citations. Were students using the recent last 10 years? Were they using older references? Were they using journals, internets? What type? Because that is also an indication of the quality of the work that they were doing. If a student just uses a whole lot of internet-based references, there's no peer review. So that becomes a challenge. If students use Wikipedia, no good in academic scientific writing. So we must look there at journals. Journals, conference papers is what we were thinking that they should be using. Does the evidence support that? So this is the university profile where I am at. This was in 2015. Please remember, the study was done from 2005 to 2015. So we're looking at the profile back in 2015. We have the 4 faculties, and if you look there, 6 and 6 is 12, plus 4 is? Hello? Anybody home? Yeah, I'm catching you. 6 plus 6 is 12, plus 4? 16, eh? Plus 5? There we go. Good, thank you, Professor Bandy. I'm watching, eh? You're watching, I'm watching a cell phone, computer. Yeah. Right, so there's 21 departments, which means there effectively should be 21 degrees being offered, each one in each department. For instance, a PhD in education, a PhD in health sciences, a PhD in electrical engineering, a PhD in civil engineering, so forth. This just shows the number of undergraduate students and the number of postgraduate students. So we're a very small university. Our postgraduate students not that great, but you can see humanities has the highest number of postgraduates. In other words, masters and doctoral students sit in the faculty of humanities. Of course, that's where you have education, teaching education primarily. And if you look at engineering, we second in the amount of students we have. So if we look at the research methodology, 2014 to 2018. Sorry, that was the period. It was a 5-year period, 2014 to 2018. In that period, we could only find 72 PhDs had been completed. And those 72 would now be on the online repository. They will be on the website of the university for the public to access. We're using quantitative data, only quantitative. We're not looking at qualitative. And as we said, we had a software developer who wrote the Python code for us to download, extract specific data, and then just in Excel, we interpret a bit further. So it's noteworthy if you look here, one promoter. Of the, remember there were 72, we're looking at 72. Of the 72, 28 had only one promoter. The rest, the majority had 2 or more promoters. And that is noteworthy because in PhD research these days, they are moving away from one promoter and moving more to what they call co-promotion, with a whole lot of specialists helping out. So it is a new trend to have a promoter or a promoter in your country where you are, but also a promoter in 3 or 4 other countries who are specialists in the field. This is something new in PhD. If you look at the number of pages, who wrote more than 300? It's about 19. 19 students wrote more than 300 pages, while about just a little bit more had less than 200 pages on their PhD. And then we just looked at the file size. Why the file size? Remember, these are PDF documents on the repository. So you can see that there are about 10 that had a bigger than 12. Is it because there were more images? It's possible, but it could also be that the person hasn't encoded properly, because that can also lead to that problem. Right, if we go further, if you look at the 4 faculties again, so this just shows you the number of theses per faculty, and then theses with a co-promoter. In other words, that's the co-promoter, which means that one would be the single promoter, single promoter over there. And so you can see which faculty is doing a lot of co-work. In other words, there's more than one promoter. Health sciences. It's noteworthy, because health sciences, you can't just use one promoter. The reason being is because many times it's cross-disciplinary. So you would need to have a number of specialists there. Which faculty is using the less number of co-promotion? Humanities. Of course, that's education primarily. So they seem to be very confident in what they are doing there. If we go further, this is very interesting, ladies and gentlemen. So if we look at engineering, the average number of pages for a PhD is 218. But if you come here, Faculty of Management Sciences, there was a PhD that had 441 pages. The minimum had 166. Now that's a wide range. That does not make sense to me. The reason being is there's the same amount of credits. In other words, it's the same 4 or 5 year qualification. So why must the one student write, how much is this more? It's about 3 times more. Why must the one student write 3 times more than the other one and they still get the same qualification? That does not make sense. All right, let's move on. Here we have on the left tables. You can see Faculty of Humanities, they love tables. 120 in one thesis, 120 tables. Figures, there was one thesis that there were 60, and the average is about 24. Now, tables is very good because it helps to show that a student can synthesize. You can take a lot of information, put it together into a specific table. So that's good to be a summary and synthesis. If you look at figures, why would engineering, built environment, and information technology have the most number of figures? Well, because we do circuit analysis. There's a lot of drawings, civil engineering, mechanical engineering, so we would expect the figures there to be much. But 138 in one thesis, one PhD thesis, that's quite a bit. And you can see the averages. Averages, yeah, more or less, yeah, in line, but that is very high for engineering, built environment, and IT. On the left, references. Now, ladies and gentlemen, 762 in one thesis. 762. That's ridiculous. Sorry, ladies and gentlemen. I mean, this student had 117. Now, that's about what? 7 times more? Now, if the student had to go and format it by hand, write them by hand, or put them in the Word document he's not using a reference manager. So in the Word document, you format 762. How long is that going to take the poor student? I think it's unfair. Where this one only had, much less time, to do. So that's the discrepancies we're looking at between disciplines, which I think is being unfair to a specific student. Again, there you can see the averages. That's what you should. So in engineering, you should have about 178 references. That's the average. Humanities, health, environmental sciences, and then management sciences. On the right is the words in the abstract. So 1,000 words is seen as an extended abstract. That's okay, acceptable. But you can again see the average. It's about 482, 465, 450. And these three here is very much in line with standard abstracts you write for a journal. It's usually 300 to 500 words. So that is looking acceptable then. So if we look at the topics that were done in these 72 theses, and we're looking at graduate attributes, we're looking at attributes specifically aligned to the attributes of the university. Entrepreneurship, innovation, sustainability, and technological advances we found very much in business administration. Not so much in those two. We couldn't really find what contribution they are making. And these are also very much in line with the UN Sustainable Goals. If we look here, civil engineering was very much sustainable, but these, we couldn't really find what sustainable goal or what contribution are they really making to society. Yeah, again, management sciences and humanities, they were also working a lot on sustainability, leadership, problem solving. And then we move over to the citations, and what was good here? Journals. Students were mostly using journals in their references. In other words, they're using peer-reviewed work, and that's excellent. As soon as you use a peer-reviewed piece of work in your writing, you're already showing the reviewers that you have done your work properly. If you look at internet, it's a bit high. Other, that is the one we couldn't classify. There were a number that we couldn't classify. Either the reference had been wrongly formatted, or our Python programming just couldn't identify it. And that's what we're hoping the AI will be able to help us with, to be able to bring that other down, the artificial intelligence study that we are busy with. If you look at the tail tells you how many references were done within the last 5 years. Remember, this is 2014 to 2018, 2014 to 2018, so you can see within the last 5 years your tail peaks. So that's great. They were using recent references, so it's not based on old things from the past. And that's just a summary of what we showed you now. And you can see that journals, engineering and health sciences have the highest number of, remember, these are journal references, references to journals. And if you look at internet, who's got the highest internet? Interesting, health, environmental sciences. They've got the highest internet reference. So, we looked at 72 theses, 61% had 2 promoters. The largest number of PhD graduates came from Faculty of Management Sciences. There we have that variation, and also more than 200% in the number of pages. Again, a hectic variation. If we look over here, we can see the citations in total for those 72 were 17,720. And again, variation. Remember that one? 762 references versus 117. That's a major variation. And then 5 theses had the word development in, and 3 had the word framework in, that we could clearly see there's a contribution being made to the scientific community. Ladies and gentlemen, I thank you.
Yes, so I have a one question. Where are you jumping?
That is not part of PhD thesis, Professor Pandey. Get back to the PhD thesis. Okay, well, what happened to the jump? Sorry, can we bring the jump back? Hello? Please bring the jump back. Professor Pandey wants to know about the jump. Let's bring the jump. Where's the jump? Ah, there's a jump. So, Professor Umi, this is me, eh? You agree? You agree that's me? Or do we want to do some image processing, AI, to make sure? Yeah, it's me. Yeah, very good, very good. And Rusty, where am I jumping into? Which pool? But what is the pool's name? The Devil's Pool. Yeah, the Devil's Pool, yes. So it's the most dangerous pool in the world, eh? The Devil's Pool, yes. Does that answer your question, Professor Pandey?
So how do you survive after this jump?
How do I survive? Superman! So, of course, when you jump in here, Professor Umi, you don't jump over there. You just jump in the water, you swim to there, and then you look over, and you look at the beautiful view. Not jump. Jump over there? No, oh, then I won't be here, but I will not be here anymore. No more questions? Yes, please. Oh, yeah, we go.
I have 2,000 questions.
2001, good, there we go.
Okay, the first. If you fly to Indonesia, you see the rocket, you see the ballistic missile. Are you?
We're not flying over Qatar at the moment.
So I see this near Iran, maybe. Okay, the second question. This is a true question.
Okay.
What's your opinion if we take it the PhD with the? I see your research is one promoter, many page, two promoter, more page, many page. If have the relationship promoter with the page. Okay.
That's very good observation, eh? That's very good observation, yes.
What's your opinion about this?
So unfortunately, if you don't have two promoters, talking about a main promoter and a co-promoter, who understand what is expected of each one of them, then the one is always going to ask more from the student, and the other one is always going to ask more from the student, and they never get to a point when they say, stop, you've done enough. You see, you must from the beginning have an arrangement agreement. This promoter is going to do 3 chapters with you, that promoter is going to do 3 chapters with you, and then we know everybody what must be done. But if the one is reviewing, the other one is reviewing, add here, add there, subtract here, you're never going to finish. That's a problem. There must be an agreement up front. Who does what with you? Does that make sense? Okay.
Okay, so today we are expecting a hat trick. And hat trick requires continuous 3. Either you are taking 3 wickets continuous or 3-6 continuous. So second paper, then third paper. You have to present 4th paper.
No, but you've listened to me now. You're not going to listen to me again. Do you want to listen to me again? Oh, okay. I'm sorry, Dr. Shukla. Okay, next paper. Sorry, next paper, please. Thank you. Thank you. Terima kasih. All right, the next paper I'm going to present is for my student who couldn't come, unfortunately. Both my students are in industry, they are working, they can't get time off. And so I said, no, I will do the presentation for you. So this is a digital twin for a power supply of an ESP. An ESP, electrostatic precipitator, is a piece of equipment that they put into a coal mine, or let me put it this way, where coal is burnt. So where a coal electric energy supplier, if I can put it that way. So we burn the coal to generate electricity. Now the burning of that coal releases pollution, and it can release specific particles into the air which is detrimental to the health of citizens in that area. So they use specific filters to try and catch those particles to protect the environment and to protect the citizens. And one of the filters they use is what is called an ESP, electrostatic precipitator. It's specifically designed to catch those particles. Now, in this case, what the student had is a real life ESP, electrostatic precipitator, with a power supply. And then he wanted to create a digital twin of it. Why? Because he wants to see if he can optimize. So in other words, we want to optimize the digital twin, and then later we can go bring it into practice to see if we can optimize the one in practice and thus improve the collection of the particles, those dust particles or those pollution particles. That's what the study is all about. He doesn't want to go anywhere. Oh, there we go. Sorry. Okay, so there we go. So that's just the overview. We're not going to read it because we're going to get to each heading as we go along. Then there you can see. So yeah, you've got remember this is the burning of coal now. So you've got smoke basically from that burning process. So the gas comes in here. These are where we charge the particles that we want to extract. And then we have the clean gas, or could you say relatively clean air that exits the system. And so we need to be able to charge those particles, which means you must have a high voltage, positive versus negative. And the power supply to this ESP has the responsibility of giving that high voltage. But this voltage must be close to unity. We'll explain that soon. So let's go have a look here. So here is what the power supply looks like in real life. You'll have 4 different blocks. So you have your thyristor block, your transformer, your ESP, and then your processor. And so in other words, that needs to now be developed in MATLAB as a simulation so that we can optimize later. So there is your efficiency. That's the efficiency of collection. Remember, that must be as close to 100% as possible. So you can see K and your small v and V, your average, and your peak voltage of the power supply then plays a role. So this is just the literature review, speaking about you have to have the highest possible mean and peak voltages. But there can be a time where these voltages create a flashover. A flashover is when you get a massive spark. And that is dangerous for the system and for the power supply. So you within a boundary. You can't have a flashover, but you must have the highest possible mean. So you need to be, it's very, the limit that you are in or allowed is very small. So here's just the firing block. This developed in MATLAB. Here is the transformer rectifier unit. Again, ladies and gentlemen, we're speaking about high voltage, very high voltage. Here we're speaking about the load. So in other words, that becomes the ESP load in MATLAB. And then we have the 4 blocks put together. Remember, originally we started with 4 blocks for the power supply. Let's just going to have a look at some of the results. There you can see on top. That is the result we get from MATLAB, the AC voltage, 746 volt. And then here again, just shows us the voltage, and you can see out of the TRU, you have 70,000 volt. If we carry on there, it shows the empirical versus simulation results, and that is the end of the story, ladies and gentlemen. Questions? Hello, is anybody home? I'm finished. Can I go home now? Hey, ladies and gentlemen, eh? No, this is not good, eh? Hey. I'm going to go stand in the corner and cry now, eh? No, I'm very sad now.
Thank you so much. So,
thank you. Can
so either you will make a hat trick or we'll group photo.
I'm not going to do the hat trick because you're not listening to my hat trick. Do you have a question, Umi? No question? Can we move on? No. Good. Right, last one.
So let us go for a group photo.
Yes, let's go for a group photo. Okay, but sorry, can you I just need to show you the, oh, this is my student. Yeah, that's my student.
Very good.
You see?
It's you. No, sorry. Yes.
You have eye problems. I give you glasses. Okay, sorry, can you just put the other one in? I just want to show you the front picture, sorry. So I can just tell my student I showed you what the other project is about. Sorry, can we have the last one? Hello, there at the back, sorry, hello. Sorry. The last one, my last one I gave. I just want to show you the front picture. So I can just tell my student I did show something to you, otherwise I'm going to have to lie to him, and I don't want to lie to my students, you see. This has got nothing to do with computer science, you see, it's electrical engineering. Okay, so this one is about a train station, or a railway, not a railway, it's a train. Train, what is the word I'm looking for now? It's a railway system where they transport coal from one part of the country to another part of the country. So remember the previous one was about burning coal to make electricity, but now this one is about getting the coal from where you dig it out. I think that that gentleman spoke about heavy equipment just now. So you dig out the coal or the gold, but now we move that coal to where the power plant is, where the electrical power plant is. But now the problem is sometimes you need to go through a tunnel. This railway or this train must go through a tunnel, and then you lose communication. So we're looking at how do we maintain communication in that tunnel. Of course, in the old times we used to use analog systems, but analog systems are being phased out. And so this looked at digital. What digital systems can we use? And the four systems he looked at, I'm just going to show you quickly. The four systems he looked at was Tetra, LTE, and DMR, digital mobile radio. And we came to the conclusion that DMR is the best to use in this research. Then all he went to do is he built himself a DMR system, he implemented it, and then I just want to show you this. So this is a WRAP software, and it shows you the yellow. The yellow is where you, or the green is where you have reception. These areas here, there is no reception for this transmitting and receiving. And so that is where the railway runs over there. And so through means of the system, he proved that we can replace analog with DMR. And that's just the practical versus simulated results. And then I just want to show you, there's a student, eh? This one, yeah. Nkosinati na klankla na yawase. Nkosinati na klankla ni yawase. Right, group photo, thank you very much. Thank you. Terima kasih.
Thank you so much.
Right, group photo. Let's go.
Oh, yeah. Group photo.
Is there another presentation?
Yes. We will get the line.
But there's no more presentation. Okay, good. Thank you.
Nice picture.
No,
it's you.
You can hear this one.
Bu Dekan ikut nggak? Iya dong, ikut dong. Now, Pandit इधर आइए. Pandit ji, come this side. Come this side now.
Yeah, better light off. Yeah, that's better. Yes. Now that's beautiful. beautiful photo, eh? Wow, look at the smile. Yes. Very good. We need this one guy to finish, eh? When is this one going to finish? That looks very good.
Photo session.
This photograph is never going to finish.
Kokisa, are you hearing us? Yeah, Mr.
Yes, yes, I can hear you.
Yeah, please share your screen and start your presentation.
All right.
Group photo, group photo, group photo.
One presentation.
Group photo, agree, group photo.
He is going to present. Last one presentation awake, he was sleeping, so no problem.
Oh, let him continue to sleep then. Let him continue.
Is Arthur James short? No, yes, good. Yes.
Okay.
Are you able to see my screen?
Yes, your screen is visible. Please continue.
Yes, my name is Kokisa Pora. I'm presenting a paper called The Usage and Benefits of JSON Nano for Deployment of Machine Learning Algorithm for Water Potability Prediction. It's written by me and my two supervisors, Professor Boyo and Dr. Malusi Sibia from University of South Africa. So this study is part of my PhD study. And the bigger study, which is my PhD, is water potability prediction using machine learning on a JSON Nano for research application. So this study is trying to answer why are we choosing the JSON Nano. So in the PhD study, we're going to develop a machine learning model, and we're going to deploy it on a JSON Nano, and then it will be connecting it to the sensors so that it can sense water, look at the features that will determine if the water is potable or not. So the introduction is that, as we know, access to clean water is very critical for our health. According to the World Health Organization, 2 billion people globally consume water that is contaminated. And this is contributing to 485,000 deaths annually from diarrhea diseases alone. So currently, the chemistry people are doing this water testing using the traditional methods, which are slow, costly, and are only lab-based. They do the physical, the chemical, and the biological analysis to the water in assessing the parameters like your pH, your turbidity, your conductivity, and so forth, and also the bacteria. So what we are trying to develop here is it's a system that is real-time and is based on the edge computing solutions. The research objectives is that how can just Nano enhance machine learning deployment for real-time portability prediction of water, and what are its key benefits. So a Jetson Nano looks like what is on the picture there. It's a small, powerful computer which is using an embedded application. It uses 5 to 10 watts power usage, and it's around 99 US dollar, that kit, which is not expensive like other stuff. And it supports a real-time AI at the edge. So our methodology that we have used, we have reviewed the paper using the Prisma 2020 guideline, and then we have looked at the papers that are English papers that are published from 2020 to 2024, because this technology is changing very quickly, and our strengths, our set strength was just a nano, machine learning, and water portability focuses. And we, out of 26 papers, we retrieved only 7 after our criteria was used. The census methodology of the papers that we got was in line with the AI edge computing, the embedded systems, and the hardware efficiency, and the machine learning and deep learning for water quality. In our use case that we identified is that a convolutional neural network model was deployed in a Jetson Nano, and it achieved a 99.87 test accuracy, and then the Jetson Nano becomes ideal for remote and for low-income regions. And it was used for aquaculture monitoring, where there is a tracking of various parameters like water quality, fish health, environmental conditions in fish farms to ensure that there is an optimal condition for growth, and there is also a prevention of disease and in order to comply with the regulations. And here, LTSTM, which is a long short-term memory algorithm, was used to predict the behavior of the species. And it was connected to the camera where there was a video classification, water under video classification, which was performed under real-time processing. So these are the number of usage and benefits of Jetson Nano, which in terms of the themes of research, it was used for, I've already talked about the bottom 2. It was also used for underwater video classification, deep learning based sensors, and it was also used for AI drowning prevention and indoor temperature prediction. And the accuracy was also high when it was applied in a CNN, in LSTM model, and also in your GRU model. So when we compare Jetson Nano with other platforms, it's real-time machine deployment. It does not need cloud, and it does not need to be connected to the internet in most cases. So, and it's also energy efficiently. It has got low power consumption, while others like your cloud-based platforms have high power consumption due to large data centers, and they also consume more power. And then is cost effectiveness. The kit is around 99 US dollar, whereas your cloud-based platforms requires ongoing cost of a cloud storage, computation, and the bandwidth, and then scalability, compact and portable, easy to deploy in a diverse environment, from urban and to our rural settings, like in our country in South Africa. And is where others are scalable in terms of computational resource, but depend on the internet availability, which is not ideal for rural environment. GPU capability, it uses 128 core Maxwell GPU. It can handle a complex machine learning tasks efficiently on an edge. And it can integrate with sensors, which we are going to use in our studies in terms of checking the water potability using the sensors. So this is the summary of what we have been talking about. That is a real-time, energy efficient, cost-effective, scalability, GPU capabilities, sensor integration, latency, and deployment visibility. The future research direction is that federated learning approaches and nano units have to be performed. Sensor fusion for multimodal water data, so that it can sense multiple features at the same time, and it should be deployed in a broader scale in the public health to improve the condition. So in conclusion is that Jensen Nano is fast, low cost, scalable AI, ideal in a limited infrastructure areas, and great for water quality monitoring solution. That's why we are going to use it for deploying our algorithm in our PhD studies. So I would like to thank my supervisors, and that's my contact details. Thank you very much.
Yeah, thank you so much for your nice presentation. Your presentation was very impressive, and we are going to we have some professors working in this similar research area, so I will inform my colleague, will try to contact you, and if they will interested, we may sign research agreements like joint research, and we may go ahead. Okay, thank you.
Thank you very much.
Now, okay, so you may exit. This is the last online presentation. We are shifting to offline.